go to. They're a private company run out of the UK. They're not associated with the British government at all. It's like $50,000 or $60,000 per person. You can go land on a private airstrip not associated with any government organizations. They have a private camp not associated with any government organizations. You can just visit. It's just a tourist thing. You can go to Antarctica if you want.
Okay, so there's why is there a 400-mile no-fly zone over Antarctica?
I don't think that that's true.
100% that's true. Why is there no 400?
I've literally never heard that. So I don't even know if that's true. Parker, do you want to double check that?
Yeah, I'll fact check that.
Why don't you double check that?
It might be the case. But it's also like, it's not particularly easy to fly over Antarctica anyway, because it's very, very windy.
You said what? It was what again?
400-mile no-fly zone over Antarctica.
Because there are flights that fly over the South Pole, right?
Understood.
So like, if they fly over the South Pole, that means that the South Pole exists, right?
The FlatEarthSociety.org says that Antarctica is not a no-fly zone, by the way.
Oh, well, there you go.
Yeah, I see the Sheffield of Aeronautics says that Antarctica is not considered a no-fly zone, and it is not illegal to fly over Antarctica. However, there's no reason to fly over Antarctica.
Why is there no reason?
Because it's boring. It's
like,
just,
what would be? Can you
ice?
actually explain to me the point? What would you like to do it? You want to go do it?
Well, here's the thing. So what happens when? What would happen if you were to fly past?
Apparently, you can go do it. Go do it.
Apparently, you can. You can't.
Go get yourself a plane and go do it.
You can't. You can't.
No, you can. There are tourist charters that will literally fly over the South Pole. It's not cheap, but you can just book a ticket today. In fact, this is actually the best time of year to do it because it's summer. It's summer in the Southern Hemisphere.
In the Southern Hemisphere, I get it. So, okay, so Antarctica is not a no-fly zone because the Flat Earth Society says it's not. But all right, so let me ask you this. I'm gonna try to give you another. How many?
By the way, I just want to summarize. I think we're 0 for 5 right now as far as debunks of the flat Earths that you've given.
You haven't debunked anything.
I mean, do you not remember the no-fly zone that doesn't exist?
Listen,
2 seconds ago.
Because you Googled it on the Flat Earth Society.
I mean, he went to another source as well, but.
So, how many inches of curvature are supposed to be for every mile on this globe?
You can approximate it as 8 inches per square mile.
Correct, right?
It's not a good approximation though over more than say 100 miles or so.
Yeah.
It fails to reproduce the data.
So, if I'm on a plane, let's just say I'm in New York, and I fly.
Yeah, you have to tilt down in order to. You're going to bring up that, right?
Can I finish?
Yeah, sure.
I'm just going to ask you, if you have to fly that 2,600 miles or whatever it is, how do you fly? How do you fly?
You fly with your nose pointing at the horizon, and you keep it that way.
Yeah.
And you keep your altitude fixed and your nose at the horizon.
Right.
You might point slightly upwards, actually, so that you don't fall down to the ground. But yeah, you fly and adjust your wing flaps so that your altitude stays constant.
Okay, so the key word you said was horizon, correct?
Yeah.
So if I'm 30...
You would actually fly with your nose slightly above the horizon, otherwise you'd crash.
If I'm 30,000 feet in the air, which is most planes travel, why is the horizon still at eye level?
It's not.
Oh, it's not.
No.
Okay.
No, you could actually do that. You could actually check this yourself. Go get something called a theodolite. It's useful for surveying. You can basically figure out exactly where eye level is, exactly where horizontal is. And then it has a telescope in there with little crosshairs that tells you where eye level is. And then you can look at the horizon. And if you're at an altitude, like on a 10-story building, you'll see that the horizon is just a little bit below eye level.
Okay. And so in a plane, the windows on a plane, they're pretty much the same as a fisheye lens, correct?
No.
No, they're not?
No.
Oh, okay. All right, well, I guess I've been debunked.
I guess so.
Yeah.
Are you not a flat earther anymore?
Oh, I'm a flat earther for sure.
So then what the hell are you holding to a debunked theory then?
He's not gonna. He doesn't want to listen to anything I'm saying.
He's engaging and
addressed-
listening. He's been very patient with you. Very nice. Like
when I'm on a
FaceTime,
plane,
I don't think you understand the level of fucking patience that Blitz has given you, my guy. Literally, almost no one on the app would give you that level of patience.
Well,
It's actually extraordinary.
I appreciate.
Thank you.
That's good. You should respect your
Like
elders.
everyone in the live should follow Blitz right now. By the way, everyone in the live should follow Blitz right now for that.
Every time I've been on a plane, which is frequent,
Mm-hmm.
the horizon's always eye level.
Yeah, I mean, at 33,000 feet, it's going to probably be like, well, I'd have to work out the math, but it probably wouldn't be more than a degree below eye level.
Okay.
Because the Earth is quite big, and 33,000 feet isn't very high. So that's why we use instruments, right? We use like protractors to measure angles rather than just saying, it looks at eye like we use measuring devices so that we can get quantitative data and check these things, right?
Who's checking these things?
So there's a great guy on here named Baron Rutledge. He's a surveyor. It's literally his job to take measurements of the Earth. He's done these kinds of checks. In fact, he had a video that came out like a few days ago where, and he does this on lives too, where he'll just go out and measure things like horizon dip angle, measure things like, what's it called? Reciprocal zenith angles, which is two distant buildings will curve away from each other as they go higher up since the Earth's curved. He'll measure things like distances to the horizon, how far away, like he does all sorts of these things live. His job is literally to be a land surveyor. It's his profession.
Okay. So let me ask you this.
Yeah.
So you're back in a plane. If the Earth is spinning at 1,000 miles an hour on its axis, let's just say 1,000, even though you say it's not 1,000, but I'm just going to use the 1,000. How do you land?
Well, the air is also moving with the Earth.
Okay.
And so you are moving relative to the air. That's what airspeed is, right? It's your speed relative to the air around you. So all you have to do,
so the air, saying the atmosphere is spinning also at 1,000 miles.
Yes.
Okay. And where does that stop?
It gets it gradually what's the word? Not correlates. Hold on. There's a word. There's a great word. Okay, I won't think of the word, but it gradually not disconnects, but it gradually loses its relationship with the motion of the Earth as you go higher and higher. Not dissipates. I don't know why I can't think of the word. It's not dissipates though. It's decouples. That's the word. It gradually decouples from the motion of the Earth as you go higher and higher.
Now, where does it decouple? Is it like lower?
It's a gradual thing.
It's a gradual thing.
Yeah.
Okay.
Same with air pressure.
So let's use I want to go back to the sun. So
okay,
if we leave Earth's atmosphere, which we've never done, but let's just say let's just say we could Neil deGrasse Tyson this, and we get to leave the Earth's atmosphere and we're heading towards the sun, right?
Yep.
Don't you think it would be hotter the closer you get to the sun?
It is. The Parker Solar Probe, by the way, named after this guy over here. The Parker Solar Probe took a lot of serious engineering in order to make it be able to withstand the extraordinary heats that are required because it's sitting just a few million miles above the surface of the sun.
Right.
So it is very, very hot when you get very, very close to the sun. Yeah.
Okay. Now, the moon is 200 and what?
35,000 miles away, something like that.
So how is it when we have a solar eclipse that the moon and the sun are identical sizes?
Well, they're not. They're close, but they're not identical. That's why we have annular solar eclipses where the moon only covers up the middle, but there's still a ring of light. But yeah, so it's because the moon is about 400 times smaller than the sun and about 400 times closer than the sun. It's a nice coincidence.
Yeah, it's like almost impossible for it to happen is pretty much what it is.
Well, so the moon used to be much, much closer.
Yeah.
We happen to live at a time when it's just about the right distance. But it will get further away. The last solar eclipse will be in a few million years because the moon will be too far away and it won't cover up the entirety of the sun anymore. But you brought up eclipses. How the hell do eclipses work on a flat Earth?
I mean, that's my question to you, I guess. Because
Well, I mean, I can tell you how they work on a spherical Earth. You have the moon orbiting the sun, and sometimes the moon will get in the way of the sun. Sorry, the moon orbiting the Earth. Sometimes the moon will get in the way of the sun, and then it'll block the sun. That's how it works on a globe. How does it work on a flat Earth?
it's a good question.
It's a really good question. You should be able to explain that if you want to say that your model's better than mine.
I'm not saying anything's better than yours. I'm just curious. I wanted to hear what you have to say because, once again, I was a glober, and then too many things just didn't make sense.
So do they make sense now? The things that convinced you now that you've heard what's actually true about the world?
The eclipse makes total sense, but
and it doesn't make sense on a flat Earth, right?
On a flat Earth, no, it doesn't.
How do sunsets work?
You don't have to cover your mouth. It's okay, brother. Listen, I'm not.
He's just a zoomer. It's a thing zoomers do.
Yeah, it's okay. It's good.
Yeah, we are zoomers. We are zoomers. W zoomers in the chat. Yo, Static. I appreciate this.
Zoomers are
Thank you
babies.
so much.
How do sunsets work? Do you think?
Well, that's the rotation, right?
Well, on a globe, yeah.
Well, that's what I'm telling you. It's so if we're on a globe, it's the rotation, right?
Yeah, no. I'm asking, how do you think sunsets work?
Well, a sunset doesn't change. It never changes where it's at. It just it goes around. If you watch a sunset, it doesn't just go up and down from the spin of the globe.
Like, why does the sun appear to get lower in the sky?
Because it's moving in a circle.
Is it moving down?
No.
Then why does it appear to get lower?
Because it's moving away, just like your train track theory. It moves away.
Right. Okay. So in your view, you have the sun, and it's moving away, right? Like this?
No, around.
Okay, so it's moving like this.
Yes.
So why doesn't it get smaller?
Well, it does get smaller because
No, it doesn't.
it's moving. It's moving away from.
But you've seen sunsets before, right? Like,
of course,
they don't get smaller. It just goes. The sunset just goes like this.
It doesn't, though.
You
can measure it. I mean,
we've seen sunsets go like this, right? Like, we've all seen it. It goes like this.
Well, the sun. You can't see me, but the sun. Supposedly it rises in the east, sets in the west, so it's going around, right?
Yeah, it rises in the east and sets in the west, and when it sets, it goes like this, right?
Yes and no. It doesn't go up and down. It actually sets.
It goes like this or like this. It goes like at an angle unless you're at the equator, but it's neither here nor there. The point is its size doesn't change. It just gets lower.
Yeah.
Right? But if it was getting further away, it would get smaller, right?
Right.
Big, small. But that's not what happens. It goes big, down.
So the sun doesn't get smaller when it sets?
No, it actually gets about 3% bigger. This is due to atmospheric effects.
I don't know. In Nevada, where I live, it seems to be a lot smaller when it sets.
So I know why you say that, and people often say this. What's happening and why it appears that way to your eyes is because your eyes are, you know how when you get like glare on a camera when you point it at something really, really bright?
Mm-hmm. So
the sun is brightest when it's like midday. And so your eyes are basically making the sun appear bigger because of glare. That's why if you go filters, like a type of thing you can put in front of a camera, or just like some really, really dark like welding glasses.
I have a solar filter.
Yeah. So put a solar filter in front of your camera and point it at the sun in midday. It'll be much smaller than it looks with your eyes.
Yeah.
And just track the size over the course of a day, and you'll find that its size doesn't change from noon to 6 p.m., right? The size just doesn't change.
Mm. I'm trying to look something up for you right now.
While he looks that up, everyone tap the screen. Let's run it up to 500,000 likes real quick. This live is going crazy. Share the live, everyone. Copy link, send it to a few friends. Let's keep it going out to more people. If you do disagree, if you think that the earth is flat, send a guest request right now. Make sure you do so right now. If you do disagree.
All right, Blitz. So back to the curvature, the 8 inches.
Wait, why are we dropping the sunset?
Well, because the sunset is not going to prove anything either way.
Yeah, it'll prove it's not a flat Earth.
Well, so the 8 inches of curvature. If I'm standing,
hold on. So I just want you to admit that a sunset does not work on a flat Earth. Then we can move on. Otherwise, I'm not going to let you move.
What? I'll tell you the only thing so far that you've been able to share with me that proves a globe would be an eclipse.
Okay, so how does a sunset work on a flat Earth?
By the spinning. I mean, the way the moon and
on a flat Earth. How does it work on a flat Earth?
Because the moon and the sun are synchronized, spinning around the flat Earth.
Yeah. So why doesn't it get smaller? Why does it just get lower?
Well, I can't prove that it doesn't get smaller.
Yeah, you can. You can just go do it yourself.
I suppose I could try.
You say you have welding glasses. Just do it. It's like, I don't know what part of the world you're in. It's like 4:21 for me right now. You can just go get your welding goggles, put them in front of your phone, look at the size of the sun, and then in an hour and a half, when the sun sets, do the same thing, and you'll see it's the exact same size.
This is going to be a tomorrow thing because it's dark here already.
Okay, so then how about this? Go look up a video of sunsets. You'll see that it doesn't go like this. It goes like this.
I mean...
Type into Google sunset solar filter.
And by the way, guests, we won't be able to hear you whenever you're paused. So you have to come back in order for us to be able to hear you, just letting you know. And if you are paused for like more than like 2 minutes or so, it will remove you. That's just how TikTok works. And W Dog in the chat.
He's an old guy. He can't see very well anymore.
All right, so Dr. Blitz, look. So the 8 inches of curvature for every mile, right? If I'm standing on a beach and I'm watching let's just say I'm watching a freighter sail off into the ocean, right?
Yep.
And in our perspective, we watch it go over the horizon, right?
Yep.
If you take a camera that doesn't have a fisheye lens, you can zoom right back into it. How does that happen?
No, you can't. Not with large ships. No, you haven't. You may have done it with small ships where you just can't see it, but that's because you stopped being able to see it, not because it sank below the horizon, but because it just got too small to see. Your eyes can only see things that are sufficiently big. But for example, you can see with your own eyes, you can see a cruise ship dip below the horizon without needing a camera, and regardless of how strong your zoom is, you will never see the bottom of that cruise ship once it's gone further out than the horizon.
That's not true. I've done it.
With a cruise ship? Okay, show me the video.
No, not a cruise ship. I did it with a freighter.
You did it with a small ship, a ship so small that you actually just couldn't see it with your eyes at all. It's not that it dipped below the horizon. It's that it was too small to see.
A freighter is not a small ship.
Then show me the video of that happening. I don't think that you have one.
How it's not a video. I had a camera.
Okay, so you have so I just have to trust you, I guess. Trust me, bro.
Listen, I mean, what's the point of sitting here telling you a bullshit story?
Because it confirms your biases.
There's no biases at all. That's why
there's no biases.
I just agreed with you on a topic. Like I'm not biased at all. I'm curious because I want to know. I want to know the facts. I want to know the truth because I don't believe everything we've been told, and I feel like there's more to it than what we're told, and that's why I wanted to come on here.
Yeah, so I just don't think that you saw what you claim to have seen.
100%.
Maybe your eyes were deceiving you. Maybe you're lying. Maybe it wasn't actually a freighter, and it just looked big because it was far away.
I mean,
I don't know why. I would need to see some data, some evidence that this actually happened.
Okay. All right. I'm not going to argue about it with you that I did it. It's just, it's a simple, yes, it did happen. Yes, I watched a ship. And then when my perspective lost the ship, a friend of mine that I was with and I took the camera.
Wait a minute. So did it get too small or did you see it dip below the horizon?
With my eyes, it dipped and it was gone. And we were able to.
Wait, was it gone or did you only see the top half of it? That's the question.
No, right? It was gone out of
okay, so it was gone. That just means that it was too far to see. It doesn't mean that it dipped below the horizon. Yeah, so a cruise ship is a great example because cruise ships are really tall.
Mm-hmm.
Cargo ships probably aren't, so maybe that's why it's hard to see this. But on a cruise ship, you can literally see with your eyes, assuming your eyes aren't terrible, you can actually see that when it gets far enough away, you can only see half the cruise ship.
Okay.
And no amount of zoom will bring that in. So I suspect that with regards to the cargo ship, it was probably just too small for you to see, not that it dipped below the horizon. And that's why you could zoom it back in, because it was just too small. It wasn't obstructed by anything.
So you're saying a cruise ship, which is taller, please.
Yeah, I contend that you will never, ever find a video of zooming back in a cruise ship that has already dipped below the horizon.
And how many miles do you think that needs to be?
You'll stop seeing it dip below or you'll start to see it dip below the horizon about, like 3 miles out or something like that? But it'll be a while before it's significantly obstructed.
Yeah, it's exactly 3 miles. This is when it starts dipping in the horizon. So
it's exactly 3 miles if you're exactly 3 feet tall, right? Sorry, 6 feet tall.
6 feet tall.
But we stand our short kings here.
Well, I'm above 6 feet, so I'll be okay on that end. I'm gonna do that. I'm gonna watch a cruise ship and I'm gonna video it and send it. I'm gonna send it to you.
Please.
And then when I send you this video, what's your rebuttal gonna be?
You're not gonna send me a video of zooming back in the bottom of a cruise ship after you can't see it anymore. I don't think that'll happen.
Okay.
If you can do that, I'll be a flat earther tomorrow.
You would be?
Of course. That's evidence, and I trust the evidence.
Okay. So how do I send this video to you? You want me to
make a TikTok and then message it to me, I guess? My DMs are open.
Okay, yeah, I'm going to do that. I'm going to do this. I'm actually going to go do this for you tomorrow.
Please. Well, make sure that there's a cruise ship coming in tomorrow.
Keep us updated. If you want to hear the updates, chat, go join the Discord, right? And we'll put the updates in the Discord, everyone.
Yes, and I'm going to use a camera that doesn't have a fisheye lens. And I
don't think you're going to find a camera without a fisheye lens. Unless you spend a few $1,000s on a rectilinear lens, I guess.
Absolutely.
Okay. And make sure that a cruise ship is in port tomorrow. I don't know where you live, but cruise ships aren't in port every day,
No, I know. I'm sure Cape Canaveral will have one going off or something.
Okay.
I'm going to send you this video.
Yeah, please do. Get your P900 or P1000 or whatever, which flat earthers love, and then zoom in the bottom half of the cruise ship.
You hate flat earthers.
No, I've just talked to a lot of them.
Listen, I'm not an irrational flat earther. I'm just trying to figure out the facts. That's it. I just want to know the truth.
Okay. Now, when it comes out that you can't zoom back in the bottom of the cruise ship, you're still going to send me the video, right?
Listen, I'm going to take the video. I'm going to send it to you, whether it's good or bad.
Okay.
It's only fair.
Yeah. So make it so the video
what
that you should
conclusions
take.
are you going to accept if it fails?
What was that?
What conclusions are you going to accept if it fails?
That there's curvature.
So what you should do, make sure when you're filming this, just because it'll be a good way to check, is make sure that you start filming before it starts to disappear at all.
Yeah.
And then keep filming the entire time, and you should see it get lower and get smaller. Both, you should be able to count the decks if you're using a really good camera. You should be able to count the decks, and you should be able to count the decks that are above the water, and the number of decks will get smaller, right?
Right.
And then your job is to see if you can zoom in more and get more decks to show up.
Right. Now, and if the more decks show up, then that just proves right there that...
Then I'm a flat earther. Yep.
Damn. That's going to be a good day tomorrow. Hopefully there's something leaving tomorrow. I'm going to get this video and I'm going to send it...
Flat Earth Blitz.
Yep.
We'll start doing Prove to Me the Earth is Not Flat lives.
Beautiful. I appreciate the talk, guys.
Appreciate it. Have a good day.
I will post this video on my TikTok immediately, and as soon as I do, whether it's in my favorite years, I'll be sending it to you.
Wait, do you live in Nevada?
Half and half, yeah.
Oh, okay. Because there aren't cruises in Nevada.
Well, there's no water in Nevada unless you want to go to Lake Mead.
Yeah.
No, but Florida there's all kinds of cruise ships going off in Florida. So
Okay. Sounds good.
I'll get it done and I'll send it to you guys.
For sure.
All right, guys.
All right, we'll see you then.
Bye.
How much more time do you have, Blitz?
Maybe half an hour?
Half an hour or so? All right, for sure.
But if you want to end it here, I mean...
We can
just do
keep
one
it
more.
going. We can keep it going, get
Sweet,
another
sweet, sweet.
person.
My mother and my wife are out getting mani-pedis, and I think they're probably going to be back in half an hour, so we shall see. And then dinner.
Nice. Yo, what's up? How old are you?
Hello, I'm 21.
For sure. Do you think that the Earth is flat?
I don't think it's flat, but I know it's not a globe for sure.
Well, then what do you think it is?
I personally do not know. Based off the evidence, I wouldn't say I definitely know what the Earth is, the shape, but I think the flat Earth model makes a lot more sense than the globe. And I've actually looked into it very deeply, and I can destroy very easily what the globe model, proposes.
Okay, debunk gravity.
Calm down, bro.
Well, you said that you could debunk anything that the globe says.
Bro,
so
just asked you to debunk one thing. Calm down.
Yeah. I'm just gonna release 7 points.
Well, no. So you say that you can debunk any, so I'm asking you to debunk gravity.
Hold on. Gravity, first of all, we can. I'm not very versed with that. So I'm still studying.
Then don't make the claim that you can debunk every globe Earth point. My guy.
Hold on. Ships doesn't like sunsets, seasons, time zones, airplanes.
Gravity. Do gravity.
Why do you want to go to gravity?
Because it doesn't work on a flat Earth.
Wait, hold on. Do ships go over the globe?
Yes, of course they go over the globe.
That's a lie, and I can prove that.
Okay, so do you want to talk about gravity, or do you want to talk about the thing that you prepared your script for?
I want to talk about what debunks the globe. What we've all.
Okay, yeah. So if you can disprove gravity, you debunk the globe. Debunk the globe, my guy.
Why do I have to talk about gravity when I can just?
Well, because if gravity is true, then the flat Earth isn't.
I can debunk the fact that sunsets don't work on the globe.
Wait, no, sunsets do work on the globe.
Yeah, I can debunk seasons doesn't work on the globe. I can debunk.
Yeah, it does. Okay, okay, fine. Because you don't know, because gravity isn't in your script. Let's talk about seasons.
All right, let's talk about seasons. Then.
Why do you think seasons don't work on the globe?
Okay, I just want you to.
Wait, do you literally have a script? I just heard paper turning.
Oh yeah,
he probably does.
Come prepared, bro. I have to come prepared.
Okay, good. You should come prepared. That's a good thing.
Yeah.
I like it.
I don't get anything, but
It doesn't matter. You call yourself a professor or whatever, right?
I'm not a professor.
You're a doctor, are you?
Yeah.
Yeah. I see a bunch of books in the background. You must be.
This is my mom's office.
Well indoctrinated.
This is my mom's office. It's not mine.
All right. I'm just gonna turn on my camera so I can show you my little book. I think with
books equal indoctrination.
We've had a debate one time before, Blitz, but you.
Oh, we have?
Yeah, you ended the live before I got my points across. And yeah, so I'm back again.
All right, let's talk about seasons. Did you turn to the right page?
Yeah, we can talk about sunsets. The last time we were talking about sunsets before you went off. But
we got pictures. Let's go.
All right, how do seasons work? Why don't they work on a globe?
Yeah, I'll show you how they don't work on a globe, right?
Please, do it.
Okay. So, according to the globe, the sun is 93 million miles away.
Yep.
Absurd distance. I don't know how we got that distance, but let's just give.
By the way, do you want to know?
No.
Okay, you don't want to know. Okay.
Yeah, let's just give you guys the benefit of the doubt. You did your whatever lasers and all your.
Did our trigonometry? Did our radar?
So the sun is 93 million miles away.
Yeah.
And the Earth is this small. Like this is just like it's not even.
Yep.
Not even up to scale.
The Earth is very small.
You can get the concept, right?
Yep. The Earth is small.
Tell me, how this tiny Earth can be next to this gigantic sun, and Antarctica is extremely cold.
It's not next to it. It's 93 million miles away.
Extremely hot. Such a drastic variation in temperature shouldn't even be possible. Like, look at this thing, bro. You should just see.
So it's very far away. So you're going to. So it's not like it's going to burn up, right? It's very far away. The reason why Antarctica and the Arctic, the North Pole, why those places are cold is because the sun never gets very high in the sky. The lower the sun is in the sky, the more spread out the sun rays are, because it's coming in at an angle. So it'll like, think of it like shooting a flashlight straight down. The circle is smaller, whereas if you shoot it at an angle, the circle gets big and spread out, and so you end up with a wider distribution of light. So it's less concentrated and it's less hot. That's why both the Arctic and the Antarctic are very cold, because they never get more than. What, 23? The sun never gets higher than like 60 something degrees in the sky.
Okay.
Hold on, I have to actually work out the math.
Yeah, for everyone in the chat, I just want to give you a perspective of what he's saying, right? Take a ping pong ball, right? A small ping pong ball, right? Put it next to a big mash pit of fire and tell me how there's going to be...
Yeah, the sun will never get higher than like
a drastic degree
than 23.5 degrees in the sky. Anyway, sorry. Yeah, the sun never gets higher than 23.5 degrees in the sky in the Arctic and the Antarctic. So you're always going to have a low density of solar irradiance, and so those places are going to be cold.
Hold on. What I'm saying is the sun is 93 million miles away. So it's spewing out energy from 93 million miles away, right?
Yep.
And the globe model says that the sun is responsible for the variations in seasons due to the tilt of the Earth, right?
Yes.
Exactly. So I want you to tell me how this tiny Earth can make a tiny tilt to impact a very drastic change in temperature whereby Antarctica has never experienced melting and Sahara Desert.
So I did just explain it.
How can that be?
But I can explain it again if you want.
Hold on, but I'm just talking about the flat Earth model, right?
Well, I thought you were debunking the globe. Hold on, are you debunking the globe or?
I'm saying the flat Earth model makes perfect sense on the globe.
Okay, so the globe model explains seasons, and do you want me to explain how it works on the globe?
Yeah, I mean I know, but yeah, you can go ahead.
Well, I mean, if you knew, then you wouldn't be making these wild claims. So in a globe, because the Earth is tilted, the Earth is tilted during summer, the northern hemisphere of the globe is tilted towards the sun, which means that the sun is always at a higher angle in the sky. In particular, if you were at 23.5, if you're at the Tropic of Cancer, on June 21st, the sun will be literally directly overhead in the northern hemisphere, whereas in the southern hemisphere, it will not be. So during summer, whether it's the summer in the North Pole or summer in the northern hemisphere or summer in the southern hemisphere, you're going to have more direct sunlight. The sun will be more concentrated, which makes it hotter.
All right.
Seasons.
All right. Yeah. So basically what you've said is...
So we agree that seasons work on a globe Earth, right?
I for the sake of the argument and due to what we've been told, I'll just give you that. But I just want to say this.
Okay, so you haven't debunked seasons on a globe. Got it. Should we move on to the next topic?
We're still talking. You're just trying to make conclusions. I haven't even stated my points yet. So you've just said the tilt of the Earth is responsible for the changes in seasons.
You didn't listen to anything I just said, did you?
Right. I listened perfectly. And you
so repeat back to me. Why is it that it's summer?
Exactly what you said.
Why is it that it's hotter in summer in the northern hemisphere? Why? Tell me. Why is it hotter in summer?
Because of the tilt of the Earth.
Okay, so what does the tilt of the Earth do to make it hotter?
We've established this already.
Yeah, so I told you it. Now you should repeat it back to me so I can make sure that you were paying attention.
I already know it.
So tell me. If you know it, tell me, please.
When it's tilted closer to the sun and the Antarctica is tilted away, it's the winter over Antarctica.
Why does it get hotter when it's tilted towards the sun?
When it's tilted towards the sun?
Yeah, why does it get hotter?
Why does it get hotter?
Tell me. What did I say is the cause of it being hotter?
I didn't hear you explain.
Of course you didn't, because you weren't paying attention. You were just trying to think of what you were going to say next. It gets hotter when it's tilted towards the sun, because the sun is going to be more overhead. For example, if you're at 23.5 degrees north of the equator during June or on June 21st, the sun will be directly overhead at noon. Whereas on the same day in the southern hemisphere, the sun will be something like 45.5 degrees above the horizon rather than directly overhead. And that's because during the summer, you're pointing towards the sun, whereas during the winter, you're pointing away. So the relative angle that the sun appears in the sky will be different. And because when the sun is directly overhead, you get more concentrated sunlight, it gets hotter. It has nothing to do with distance to the sun. It has to do with the angle that the sunlight is coming at you.
All right. So without the tilt of the Earth, would we have seasons without the tilt?
No.
Perfect. So I just want to give context to everybody on the live right now, right? So this is how the tilt of the Earth came about according to the globe story. The Earth initially didn't have a tilt. The Earth was straight. It had a straight axis, right? So billions of years ago, apparently, that's not true. A planet-sized asteroid in space, some random asteroid, hit the Earth, and then the Earth's particle formed the moon, and then this asteroid tilted the Earth and caused the tilt. So this asteroid is responsible for the tilt of the Earth, which gives our seasons. This asteroid is responsible for killing the dinosaurs.
That's not. Wait, hold on. That's not true. None of that is true.
Moon. Hold on.
You're just making shit up now.
Yeah. Well, you can address it later on, but I have.
Yeah. I'm gonna address it now. The asteroid that killed the dinosaurs was 65 million years ago. What you're talking about is Theia, which collided with the Earth something like 4.5 billion years ago, which is a very different thing.
Did it create the moon?
Yeah, it created the moon.
Did it cause the tilt of the Earth?
It may have. That's not.
It did.
That's not. No. That's not. I'm sorry. That's not consensus.
Seasons. Without this asteroid, the Earth wouldn't have had seasons.
That's not consensus.
This globe.
I'm sorry. That's not consensus. That's like that is not a fact that this thing tilted the Earth. It may have already been tilted prior. It definitely changed the tilt of the Earth, but there's no consensus to say that it caused that it was perfectly straight before that.
Yeah. I looked into this, and it definitely says that. You have to give me your sources.
Please give me a source. But for the sake of argument, let's say that yes, that Theia 4.5 billion years ago, a few million years after the Earth formed, caused the tilt of the Earth, and therefore we have seasons. So what?
Exactly. It created the moon, right?
Yeah.
The same moon.
Theia created the moon. Yep.
That gives our months that females track their menstrual cycle. Like all that came from a random asteroid from space.
Yeah.
Perfect. Now let me go back to what I was talking about initially, right? About seasons.
Wait, so how does this debunk the globe Earth?
It shows how absurd, how gullible we are.
So this is just incredulity then. It's just this is impossible. It doesn't make sense. It can't be. It's just incredulity, right?
No. Listen to what I'm trying to say, right? Now, the Earth is 93 million miles away from the sun.
Yeah.
Right? And all the sun rays from that distance is like, there is no such thing as the sun is going to come from a particular type of angle. The sun rays from distance, like the sun rays from that distance, like it's already spread out across space. So the rays that are reaching the Earth, there's not going to be such a drastic difference that is going to.
It has to do with the intersection of the parallel rays coming from the sun as it intersects the surface of the Earth.
Bro,
you actually showed it on your picture.
You don't want me to talk. You just yap over me all the time.
It's only yapping if you don't know what you're talking about. So with respect, I'm not the one yapping here.
Why wouldn't you let me finish my points?
You said something untrue, I was going to correct you.
Like I was saying, right?
Because you were gibberating.
No.
Jim?
The same.
You were gimmerating. If we could say it that way.
The same thing applies for the reasons why the time zones are very ridiculous on the globe model.
Oh, right? So now it's time zones? I thought we were talking about seasons.
Yeah, because we're talking about still on seasons, but I'm just extrapolating to say time zones as well.
Time zones and seasons aren't related.
Actually, we're gonna go to what the flat earthers present, because I think you guys are doing.
Hold on, before we change topics completely, because you can't explain how seasons don't work, I'm actually just going to draw you a picture real quick. I found a piece of paper, I found a pen, I'm going to draw you a picture. You like pictures, right?
Draw whatever you want to draw. Yeah, I love pictures, bro.
All right. So here's our Earth exaggerated, right? Oh, sorry, let me flip around my camera.
Can I explain seasons on the flat Earth before we move on?
No. First, let's show you why this works. Right, here's our Earth. Sun rays will be coming in from the left. Let me draw those. I'm going to try to draw them equidistant.
Yeah, while he's drawing, guys.
Can we get a W for the graphs, everyone in the chat?
Here we go. Okay, here are the sun rays coming in from the left. Here's the Earth. This is going to be during the summertime for the northern hemisphere. This is north. This is south, right? So what I want you to look at is I want you to look at the size that these two sun rays are apart from each other. See how far apart they are? And now look down here. See how far apart they are down here? They're so much further apart. These sun rays are more spread apart in the southern hemisphere than they are in the northern hemisphere because of the tilt of the Earth. And when the sun is coming from the other side, they'll be more concentrated on the southern hemisphere than on the northern hemisphere. And so you end up with seasons, more concentrated sunlight in the northern hemisphere during summer, and more concentrated and less, during June rather. So this would be like June, July, October, or June, July, August, and less concentrated sunlight during winter in the southern hemisphere. And in fact, this also explains why if you are at the 23.5 degree mark, right about here, you never see the sun at all during those months because the sun just can't get to you because the earth is in the way.
All right. That's what you propose, the globe. Okay.
This is how seasons work on a globe. So does it make sense now, or are you going to debunk this?
Can I explain how it works on the flat earth? For contract?
Yeah, sure. But before you do that, just so you know, you came on here saying something along the lines of, I'm going to debunk every single thing that the globe uses to explain how the globe works. So it doesn't even have anything to do with the flat earth. The point is you claim that seasons don't work on a globe,
flat earth model
but they
makes
do,
more
right?
sense than the globe.
Well, your claim was that seasons don't work on a globe, right?
Yeah, like it doesn't work. Like I just showed you. How would you take
wait? So then, what's wrong with this picture?
That picture is crazy because
what's wrong with it?
The sun rays coming from 93 million miles away will not come from that distance and suddenly cause a variation or a drastic variation. It's like taking
what's wrong with this picture?
Wait. It's like taking
these sun rays are less concentrated in the southern hemisphere than they are in the northern hemisphere.
Fire, a big ball of fire, and you expect that ping pong ball to have variations in the way it burns.
Yeah, look how less concentrated it is down here, and how more concentrated it is up here.
This is how small the Earth is, standing next to the gigantic sun.
Yeah. The sun is like way over here. The sun is way in this direction, right?
Like this is crazy. Antarctica
I'm just zoomed in on the Earth, okay?
Like coming from a gigantic sun. So this gigantic sun is going to.
Is the sun more concentrated here than it is here? That's all I ask.
Change from this, and the heat is just going to make everything just from this gigantic big ball of burning fire, bro. Come on.
Yeah. So like it's more concentrated here than it is here, right?
And I'll debunk. We also
is it more? Hold on. Is it more concentrated here than here?
It is not concentrated anywhere, bro.
But it's less spread out here than it is. See how this line is twice as long as this line?
The size of the sun and how far away it is.
Do you see this line?
There is no way that
this line is shorter than this line.
Different to cause different
this line
to this extent
short,
of Antarctica
this line
being
long,
cold and the Sahara days are being extremely
short.
hot. Such a variation should never even occur. Look at your model, bro.
Short.
Hold on, I'll show you the flat Earth explanation for seasons.
Long.
And then you be the judge.
Short.
You be the judge on which one sounds more logical, right?
Long.
Let's go. Okay.
Short.
Okay, I'll be the judge of that. I'll be the judge of that, Jim.
All right, let's hear it.
You be the judge, Packer. I think you're being honest, like, cause Blitz.
I got you.
I'm not being honest. 100%. I'm getting paid by NASA.
Of course, we know that.
Dude, he gets paid right from Soros. Same here.
We know that. Of course, you don't need to tell me about that, bro. I knew that ever since. Okay, Parker. So this is what the flat earthers propose, right? Antarctica goes all around the flat earth, right? Holding water.
So it's an entire ice wall around it.
It's not like an ice wall, like a shoreline, right? Like a lake.
Okay.
Yeah, it keeps the water in. Reality is water has to it needs containment, right? A lake. The world is just a big lake with the islands being our Earth, our continents, right? So that's just what it is. That's the fact of the matter. So
are there more continents on the other side of the shore?
We've never been on the other side of the shore, so we can make positive claims like the globe does, and everything they do. But anyway,
so you don't know. Okay.
Let's get to seasons, right? So the sun is small and it's local, right? And because the sun is local, it hovers over the surface of the earth like a spotlight, right? As it goes around, causing day and night, it goes around, causing...
Yeah, how come it doesn't get warmer if you go higher up in the atmosphere under your model, since it seems to be in the atmosphere?
I didn't say it's in the atmosphere.
So it's outside.
I'm just saying, I'm just proposing, like, I don't know if it's reflecting of like if it's outside of like the Seth dome that the flat earthers believe in. Mind you, I'm not a flat earther, bro. I'm not a flat earther. I just see their model makes a lot more sense than the globe. That's what I'm like right now. I'm really.
You are a flat earther.
I'm on the fence, bro.
If you think the flat earth model is a better model than other models, then you are a flat earther.
Oh, hold on.
be
No, no,
like
no.
smaller?
You won't be able to see it. Everybody has that conception, but it's a misconception. Do you know what?
Then wouldn't it be
perspective-
smaller, right? And if
Do you-
it was the case that like a sunset was when it got smaller or farther away from us, how come
Parker.
you can attach a camera to a drone, go up like 50 feet in the air, and then see it again?
Parker, I'm gonna blow your mind right now. Okay, picture
Blow
this. You're standing on the beach, right? Oh yeah, I was talking. Okay, let's say this is you. You're standing on the beach, right? You're looking into the horizon. Okay, you're seeing the sun going below the horizon. Correct? Do you accept that this is what you would see if you're standing on the beach looking into the horizon? You're seeing the sun.
I would see it get smaller and smaller and smaller until I couldn't see it anymore.
Yeah, but this is what we see when you stand at a beach and you look into the horizon. You see the clouds touching the foreground. You see a boat going over this same horizon. You see the sun going over this horizon. Now, I want you to understand that this horizon is simply optical. It is not geometric, right? It is not a physical curve. This horizon is simply due to perspective. Just like if you stand in a long hallway, say 1,000 miles long hallway, you will see.
Then why doesn't the sun
ceiling
get
and the floor-
smaller?
The ceiling and the floor of the hallway will appear to touch each other.
Jim,
at
why
a
doesn't it get smaller then?
Hold on, let me finish what I'm trying to say, and I'll explain that. Okay.
They can never answer that question.
So
This one question
when you look at train
destroys
tracks,
flat
right,
earthers.
Parker, I'm trying to explain something to Parker. Blitz, would you wait? When you look at train tracks, right, at a distance, you think the train tracks are touching each other. But you know for sure that they are not actually touching each other. They are actually parallel, right? That's what we call perspective. That's how it works. So at a far enough distance, things are going to appear to touch each other. Things are going to appear to converge. That's why you see the clouds and the ground appear to touch each other at a distance. This point where they touch each other is not a physical curve. This is an optical curve. It's an optical horizon. And I'll explain further by saying this, right? We're in the US, right? Okay, we're in the US.
Wait, we're kind of diverging from seasons.
No, yeah, he's scared because he's scared of this. He knows this. That's why he's scared. We're in the US, right?
We could talk about it, but I thought the point was that you were going to present how seasons work on a flat Earth, and then Parker was going to judge it.
He's trying to run so bad because I'm about to blow your mind, Parker. Listen.
Okay, we'll do that, and then we will go back to the seasons.
Yeah,
okay, cool.
we in the US, right? And you're looking over the horizon in the beach, and you've gone just this far, and you're seeing this ship disappear. Like this is actually mad far, right? You're just standing over here, and you're seeing the ship disappear from bottom up, and you're telling me you saw the curve, you saw it go over the curve.
Yep.
And then you see the sun and the ship disappear on the same horizon, and you're telling me you saw it went over the curve.
Yep.
This ship went over the curve.
Yes.
Does that make sense to you? Let me tell you what's actually happening. Right? This is how.
Wait a minute. Before you do that, can we just acknowledge that does this actually make sense to you is not a good argument?
To flex so bad.
No, I'm just addressing your argument. Or rather, I'm addressing your lack of argument. You said this just doesn't make, or actually your statement was, does this make sense to you? Incredulously, of course. And that was your whole reason why it's not true. But it's not an argument, right? You didn't actually use any facts. You didn't use any data. You didn't use any mathematics. You didn't use any observations. You just said, this is crazy.
Bro, you're saying I didn't use math is just descriptive, bro.
You're right. Math is descriptive. So describe it mathematically.
Math and you think you're smart, bro. Math is just a language. I can say.
I know, and I speak it fluently, and I think that you're probably learning it at a second grade level.
It doesn't mean Santa Claus exists, bro. If I calculate how far Santa Claus is from my house, it doesn't mean he exists, bro. Math is descriptive.
That's very true. You're right.
Yep. So don't try to bring up math and think you're smart because
math is used to describe observations, and so if we want to talk about observations quantitatively, we should use mathematics, right?
Yeah, real life, not
yeah. So let's describe our observations mathematically. That's a useful thing to do, right?
Parker, I was saying something to you, right? You in Alaska, right? You're looking over the beach, and you're seeing this boat disappear from bottom up. Mind you, you're still in the US. You haven't even gone out of the US, and you're telling me you've seen the curve of the Earth. Just still in the US, in Alaska, by a boat disappearing, bottom up? Bro, that's weird.
Yes.
Because of perspective and things appearing to converge at a distance like this picture
Jim,
shows.
yeah, I think that we can see curvature. I think that you can't explain why the sun doesn't get smaller.
Wait, see.
I think you're gyrating.
Right? The sun just goes away. And because we see in domes of vision, right? we see in domes of vision, at a distance, you would think the sun and the boat are all converging at the same place because of that perspective, because of how you see. That's just how you see. So your eyes trick you into thinking that the boat, the clouds, and the sun are all on the same line.
Here's a really important question. So, like, you know how when you're looking, at clouds in the distance?
It's not a physical.
Hold on, Jim.
You're not even.
Hold on. I think we can agree on something. Jim, I think we can agree on something. We agree that the clouds in the distance get smaller, right?
Clouds in the distance get smaller.
Yeah, when the clouds get close to the horizon, they look smaller.
Yeah, they do, of course.
Okay, but the sun, when it gets close to the horizon in the distance, doesn't get smaller. Why not?
Okay, would you agree that if something is closer to you, like a car, say a car drives past you, as the car goes away, would you agree that the rate at which it changes in size as it goes away is smaller than the rate at which an airplane is going to change in size as it goes away? Okay, let me give
How
you...
are you... Hold on. Wait, you asked me a question. Do you want me to answer?
No, I'm not done. I'm not done with the question.
Okay, so you don't want me to answer the question. And by the way, just for the record, for the chat, he didn't answer my question.
After I'm done, you answer, okay? Now...
Well, you didn't answer my question.
Well, Jim, let him respond, and then you can finish the rest of it.
I actually would just like him to answer my question.
You didn't ask me any question.
I did. Why is it that the clouds get smaller, but the sun doesn't?
This is why. This is the answer I'm giving you right now.
Okay.
So
where
the car goes past,
it should begin with because. That's the how you answer a why question.
You're gonna understand the answer at the end of the explanation if you would just let me talk.
Please.
As the car goes past you and it just went like say 15 kilometers away from you, but you already experienced a drastic change in size as that car went past you, right? A plane above your head, which is already further away from you, goes about say 10,000 kilometers away from you, further than the car did, but you still relatively see the plane the same size. Now that should make you understand
that
things are already further away from you. They change in size drastically smaller than the things that are closer to you. So because clouds are not that far ahead of, like far away from you as the sun is, the clouds are going to appear to appear smaller as they go away from you. But because the sun is way above the clouds, right? It's going to seemingly appear to be the same size as it goes away, as it just moves away.
So,
and the reason
unfortunately for you, you can't have your cake and eat it too.
No,
so there's a problem. No, there's a problem with this, and I know exactly what you're saying. And
in
it's
Alaska,
clever.
and you expect to see the sun change.
So it's clever.
It's going away. It hasn't gone away to a point.
Let me address what you're saying, please.
The clouds change in size.
I know what you're saying.
They're just down here, right? In
but
this
I
vision.
am cleverer.
The sun is way above, so it will not really show that it's changing. But it's gonna appear to converge.
Okay. Let's draw a picture.
Yep. Bring it up.
Right. Okay. So I'm going to draw two different scenarios, right? One in which the sun is very high. Sorry, I just have to draw. Give me a sec. One in which the sun is very high and moving further away. And one in which the sun is quite low and moving further away. Right? Okay. We have two different scenarios. Let me actually just finish drawing it. One sec. So you have a person in both cases where you have high and low, right? So you have, come on, focus. Focus, there. The sun is very high, the sun is very low. So you're right. In the case when the sun is low, it will appear to make smaller and smaller angles with the horizon. Let me just draw some more pictures. So these angles will get smaller and smaller. And eventually they will actually get quite small if the sun is sufficiently low and you're looking sufficiently far away. And so, but you're saying, well, the reason why the sun doesn't get smaller is because the sun is very high, right? It's not low like the clouds. The sun is very high. But if the sun is high, then it doesn't matter how far away it gets. It will still appear quite high in the sky. Come on. So you can't have your cake and eat it too. If you want to compare it to the clouds, which would be like down here, yes, the clouds will get close to the horizon and they will shrink faster because they're lower. However, if you're talking about the sun, which if your claim is that it's very high and that's why its size doesn't change, well then it also wouldn't get lower than about 20 degrees above the horizon or whatever. You can't have both. It can't be both very high and get low close to the horizon. It doesn't work.
I didn't say the sun doesn't ever get lower, right? The sun just goes
wait a minute.
away.
So how does it approach the horizon?
It goes away, right?
Why?
Like I said,
why
due
does
to
it go away?
perspective.
No. So due to perspective, that's what this drawing is. We're talking about the angle that the sun makes with the horizontal, right? This is the angle. This is the perspective that you're talking about, right? It's these angles here. These are the angles. You see that the angles get smaller. It starts off 90 degrees in the sky at noon. And as the sun gets further away, that angle gets smaller and smaller and smaller. But you'll notice, even when the sun's very far away, it's still above the horizon. You can't have both.
That's why I'm telling you that the sun just goes away and it converges due to perspective.
It won't converge. If it's sufficiently high, it won't converge. So how high is it?
Now you want me to make a positive claim?
No. So if it's more than like, I don't know. We can just work out the math.
So mathematicians, you assume numbers and make up shit.
Jim, so we can work out the math. We know roughly how far away it is from the United States to China. It's like 12,000 miles. That's on the opposite side of the world. So hold on.
Right?
The furthest the sun can get away from you horizontally is like 12,000, 15,000 miles, something like that. That's the furthest that the sun could get away from you. Now, if the sun is
that your belief?
Let me finish. Please let me finish.
Is that your belief?
No, we know how far away China is, right? We can take boats.
What?
We can take boats. We know how far away China. I guess you don't know how far away China is, but anyway, I know how far away China is.
Right now, you're just trying to make up stuff.
I'm not making up stuff. So let's figure out how high must the sun be so that it appears, say, 1 degree or less above the horizon, right? We want to find h.
Exactly. Hold on.
Right. So let's say that it's 1 degree above the horizon when it's 12,000 miles away at midnight, right? So we can just do some math here, right? So tangent of theta. Jim, do you remember your geometry? SOHCAHTOA. Parker, you remember this, right? SOHCAHTOA, trigonometry.
Bro.
All right.
Made up all those numbers.
Tangent of theta over equals h divided by 12,000.
Wait, Jim, hold up.
So Parker, you got a calculator on you because I don't.
I do.
All right.
My phone, I can pull out an actual calculator if you need.
So I want you to take the tangent of 1 degree and multiply it by 12,000.
Bro, this has nothing to do with math. You just bringing up math so you sound smart and you made up all those numbers.
Yo, Michaela, thank you for the $20. I appreciate. Thank you so much. And Claudia, thank you for the $10 on PayPal. Thank you so much.
And make sure it's degrees, not radians.
Yeah. So tangent of what?
Bro,
tangent of 1 degree.
So bad, bro.
1 degree.
If the sun is low,
multiply by 12,000.
Bro, it's deflecting so bad, it's embarrassing, bro. Blitz.
I think I need to do it on my other calculator. Give me 1 second.
Okay.
Blitz. If you are in the USA, right, and you're looking over a beach and you're seeing a boat, the sun, and the clouds, mind you, this is how we see. This is how we see in reality, bro. I'm not making up shit. I'm not making up numbers.
Neither am I. This is just trigonometry, bro.
This is how we see, right?
It's just trigonometry. Man got his TI-89.
We see a boat.
TI-83.
And we see
TI-83. Okay.
Going over the curve.
Okay, so you said what was it again?
So tangent of 12,000 times tangent of 1 degree.
And we're seeing this boat going over the curve. How is that possible for a boat?
That's about 18,688.89.
You're in radians, not degrees.
Oh, radians. How do I change it? Fuck.
You should go to mode. There should be a degree or rad thing.
Okay, I got you.
These guys are just trying to deflect to math and numbers. They made up all those numbers. They are not even real numbers. He just assumed the distance of the sun, and he's gonna make up some number and say, because you don't know this number, your claim is false.
Wait, I can just try to find out my phone. I'll just look up a tan calculator.
Hold on, I can just approximate this. We can do this. We got this. So 1 degree is pi over 180 radians. So 12,000 times tangent of pi over 180. Pi over 180. Well, that's like 3 over 180. So that's like 1/60th. So this is 12,000 times the tangent of 1/60th or so. Now the tangent of 1/60th is about 1/60th. So this is about 12,000 divided by 60. So that works out to be what?
Unicorns right now.
It works out to be about 200. So we'll find that the sun has to be no more than 200 miles up. See?
208.8.
The math is where it's at. So the sun has to be no higher than 208 miles up. If you want to see the sun dip below 1 degree when it's 12,000 miles away, which is the furthest away the sun can get on your model.
Why are you making up shit, bro?
I didn't make up anything. This is just really basic trigonometry.
No, you made up all those numbers. I'm asking you.
There's only one. Wait, how far away do you think China is?
I'm asking you a simple question.
How far away do you think China is?
Blitz, don't run away.
I'm not running away. This is a really easy basic question. How far away do you think China is?
Blitzing.
I'm not deflecting. I'm asking
Yeah, no,
a very
Jim,
direct question.
answer the question. How far away is China?
How far away is the UK?
From me? Well, right now,
Out. If you go the other route.
it'd be like 13,000 miles.
How far away is Hong Kong?
Is Hong Kong is like just off the coast of China, right? So it'd probably be around the same distance.
What's the precise number?
I don't know. I'm not at a computer, but you can Google it.
Yeah, exactly. You want us to start Googling shit because that's what you want to get to.
Well, no. I mean, but like, do you think
question.
that humans don't know how far away China
I'm
is
asking
from
you
like
a simple
California?
question. If you're standing at a
Wait,
beach,
hold on. I asked.
Why
No,
are you
I'm sorry,
deflecting from this,
Jim. I asked you a very simple question and you answered it with another question.
I think you should be a good moderator and give us time to explain ourselves because we're just talking.
Well, I want you to answer his question. I really do.
How far away is
How
China?
far away is
Answer mine.
China? How far away is China from California?
I can Google it right now, and I see.
Googled it. Okay, Googled it, and it's 6,700 miles almost. Okay.
Oh, that's much closer than I thought it was.
Now I'm just asking. Okay, yeah, we got your
Okay.
answer.
So wait a minute. Wait, hold on. That's even worse for you. That's even worse for you. When the sun is in China, so when the sun is over China, and you're in California, if you want the sun to be at 1 degree above the horizon, replace this number with 6,700, and so you're gonna get like the sun should be 120 miles up, not like 200 miles up. It has to be even less. And so that means that your sun is really, really local. 120 miles is very, very, very close.
You've made your statements. You've made your claim. Would you let me talk now?
Can you address it though?
Would you let me talk before you?
Yeah, he is letting you talk right now. Go for it.
Can you like address the
please
claim?
address
but you want me to like I asked you a question. You haven't addressed my claims, but you just want to monologue and make me address your claims. You have to answer mine first, right? Because I asked first. I asked you a very simple question. I was even talking to Parker, but you just came in with the numbers. I was talking to Parker about the sunsets. That was the question. How does sunsets work on the flat earth? And I was explaining it. You came up with numbers and started talking about China.
Yeah, because it doesn't work on a flat earth.
Yeah, but
we just did the math.
You didn't let me finish my points. You just rambled over me and you brought up numbers and made up fake
I'm sorry, numbers scare you. That's fine. But I'll refrain from bringing them up in the future.
I know you love numbers so much. When you off the live, start doing Santa Claus and calculate. Put some milk and cookies too. Maybe
it's actually a really good video idea. Maybe I'll make a video about how fast Santa would have to travel or something.
That's
a good video. Yeah, I appreciate that.
That is actually a really good video.
Yeah, don't forget the unicorns too, because I know. Calculate the unicorns and all that. Yeah.
Well, that's essentially you believe the Earth is flat. You believe we're like fucking floating on. Like, dude, like, what are you talking about?
Now, Parker. The thing is, you've not even looked into that, right? You're just one-sided. You're just one-sided right now. I don't blame you. For that.
I think that you still haven't sufficiently explained as to why the sun doesn't get smaller. Yeah, because you guys won't let me talk. The two of you guys. I'm definitely letting you talk, and I'm not even saying anything, bro.
Okay, bro. But just watch this, right? When I start explaining, just watch Bleach.
No, you haven't drawn it to scale. If you're no, I'm not going to accept your drawing because you haven't
wait, Jim,
drawn
he's
it
letting
to
you present
scale.
it. Let him say something quick, and then you'll be able to continue. It'll just be for good flow.
He literally promised he was going to let me finish. He's not letting me finish.
Jim, he is going to let you finish. I promise. Right? I just want him to be able to add something real quick to like be good for the production.
So you told me this is the same drawing. It is not. It's not the same scale.
Adrian, thank you so much for the $20 on Cash App. Thank you so much. W. Adrian.
This is the same, but just from another perspective. Can you not use your brain? So
I am. It's a different scale. I'm not willing to accept something that isn't drawn to the same scale.
This scale I've drawn this to is to the advantage of the globe. So bad if you don't.
No, you've drawn it to a disadvantage of the globe.
Because of what he's doing right now, Parker, you see how he's interrupting me? I'll have to start my explanation.
No, he was just giving you that one thing, and now you can explain, Jim. I'm giving you the space.
I know it's not to scale. The mountain and his head was that up to scale? Is your head as big as Colorado?
I didn't claim it was to scale.
But I didn't claim this was to scale either. I said this is another perspective that we can look the thing in.
And I'm just pointing out that as long as it's not to the same scale, we're fine.
My points and you destroyed it now.
Jim, go ahead. Jim, go ahead. You're demonstrating consent.
Go ahead, Jim. Go.
Yeah, but would you just tell Nixie to not interrupt me this time?
Yes. Yeah, I think think he's heard you.
Yes, Nixie, please don't do that again. You just break a promise. Like that break my heart. Yeah. So like I was saying, right? We are standing over a beach. We're standing at a beach. We're looking over at the horizon. We're seeing the clouds appearing to touch this horizon. We're seeing the sun appearing to touch this horizon. We're seeing the boat all appearing to line up exactly at this horizon. Now, Professor Nixie here claims that this location is a physical curve. That's here is where the curve of the earth causes this sun to disappear, causes this boat to disappear, and causes this cloud to dip over the curve, right? So, and I showed now this picture of the actual curve of the earth, and I said, this is the same thing, but from another angle of view. We are standing over in the US. We haven't even gone anywhere. We're still tiny dots of speck of dust in the US. We're looking over the beach, and we're seeing this ship, which hasn't even gone anywhere on the earth, disappear. Disappear. We're seeing the sun disappear at the same point with this ship, at the same horizon with this ship, and we're seeing the clouds, just the tiny clouds over here over my head, disappear at the same point with this ship. And this guy is telling me that all of these three things, the ship, the sun, and the clouds over my head, disappeared over the curve of the earth. Do you now see how absurd that is? So that
how far is that horizon, Jim?
That makes you understand that the horizon is an optical horizon. It is not a physical point, right? It is created because your eyes converge things at a distance. Like if you stand in a hallway that is very long, you will see the ground, the ceiling, and the floor appear to touch each other. If you stand in train tracks, you will see the two train tracks appear to touch each other, but you know that the train tracks are parallel. This is how our eyes works. The sun is not actually touching the horizon or going below it. These clouds are not actually converging with this horizon. If they're just appearing to touch this horizon because of perspective, right? So if say Parker takes a boat and he starts going over here, he's not going to see the clouds like going over the curve. Like he is still in the US, guys. He hasn't even gone out of the US. He is still in Colorado. He hasn't even gone out of Colorado. And you're trying to tell me he's seeing the curve of the earth from here with the sun and the ship going over the physical curve? How does that make sense? Now, this is how the flat earth explains this, right? We see in perspective, the sun is not that far away. It's not 93 million miles away for sure. Now, the clouds this is Colorado. This is how we see. We see in domes, right? Our eyes makes us see things in domes like this. So we are still in the US, right? We're in Colorado, but because of perspective, our eyes at a distance make this ship appear on the same optical horizon.
Okay, Jim.
And as the sun.
You've said this 12 times.
Hold on. They all converge at that same point. And because of how our eyes work, we would think that ship disappearing, it actually went over a curve. But because our eyes sees in dome, it did not went over a curve. It went over an optical horizon. So when it gets out of our dome of vision, it gets into the other person in Atlanta. In his dome of vision, he's going to see this ship appearing from bottom up into his dome. And he's going to see the sun appearing from bottom up as well in his own dome. That's why we have time zones. That's why it can be 2 o'clock here and 3 o'clock here and 4 o'clock here, and it can be dark here, but it's still light here because the sun just goes over these domes of vision. And we, as tiny as we are, we think we're actually on a globe, but we're not on a globe. That's how our eyes work, and that's how we see, guys. This is how we see.
Oh, okay, Jim.
This is the truth.
Jim,
there is no.
That was 3.5 minutes, Jim.
Haley, think of the $4
okay, Jim.
Cash App. Go ahead.
All right,
you got it.
Everybody, tap that screen. Parker can't get gifts. He's got it messed up. So either subscribe, Cash App, whatever. Thank you for hosting this, Parker. Give it to the host. Okay, so here you are on the beach, and let me draw it to scale. The reason you can't see it is it's dipping away from you, so you only get to see part of the boat. The sun is also over here, so it's not this giant curve that you're showing way too much of the earth. This is 20 miles. or 10 miles, depending on the size of the boat. So it's not that much of a curve. As we talked about, the Earth dips 1 degree every 69 miles, and you got to love 69. So that is what's happening right there, is it's dropping. So the sun is dropping below the horizon. And this is why if Parker puts a probe up here and he puts his drone up here, Parker can then see the entire ship can be brought back in, or the dome, because he's seeing over the curve. And that's why I told you, you have to draw that horizon to scale.
All right, Professor Blitz, this is what you just drew, right? Parker is standing over here. He's looking at the boat, and then he's able to see the boat. If he goes up with his little probe, he can see the boat again, right? Now I want you. Yes, exactly. Now I want you to keep drawing it to this level, right? So mind you, Parker is in Atlanta, and this is an experiment Parker can carry out with this boat, right? He's still in the U.S. So if Parker continues and goes to, say, Atlanta, and he continues to do the same experiment, this same experiment you just showed us, right? That will make the curvature of the Earth be visible from a plane. If Parker can use his naked eyes to carry out this experiment and his tiny little probe, that will make the curvature of the Earth be tremendously visible from... So
have you ever been in a plane, Jim? Jim, you've gone over this ad nauseum.
Hold on.
No, Jim, you keep talking about an airplane, so let's talk about the airplane. Have you ever been up in a commercial airplane?
This is what you would do now. You would deflect.
No, Jim, you brought up the airplane, Jim.
Yeah, I've been in a commercial airplane, yeah. Okay.
Do you see more of the Earth when you get up in an airplane? Do you see more of the Earth or less of the Earth the higher you get up in an airplane?
More, for sure more.
You see more, right? Yep. That's exactly, you're seeing over the curve. There you go.
No, you're not seeing over the curve, because the horizon rises up to your eye level. The horizon rises up to your eye level no matter how high you go. If you take a weather balloon right now, go on YouTube, Parker. I think you're in a good place to do this. Go on YouTube and just put in weather balloon 50,000 miles up. You will see the horizon, which I told you already. I told you that the horizon is optical, right? You will see this horizon rise up to your eye level, showing you that this is simply an optical location and not a curve. If we lived on a ball, as you went higher, you are supposed to see the horizon stay consistent and drop as you go higher. But the horizon doesn't. The horizon rises.
The horizon is optical. Your eye sees the horizon, but you see more because you're still getting a horizon. The horizon is just physically further away. You can't determine how far you're seeing with your eyes.
Hold on.
Can you tell me how far something is by just looking at it?
Now you're just
Jim, look up any photo of a weather balloon that shows curvature, and shows the globe. You'll see that it shows curvature.
Because it's the wide angle lens fisheye. Show the video right now on live. Let's see.
Well, this is just one of the images.
Yep. Oh, there's the curve.
No. That's a wide angle lens, and I've seen that. If you'll watch that video, continue watching that video. When the balloon pops, right, you will see the curve go convex and concave. That's because of the lens. Hold on, just keep watching the video.
No, it's rotating.
It will go convex.
So it's because it's spinning. Jim.
Hold on.
You interrupt me more than I interrupt you.
That's impossible. That's not even possible, bro.
So when it breaks, what's going to happen?
To the end.
What's going to happen, Jim?
Parker,
the camera is going to spin. And as the camera spins, if it was an optical illusion, the Earth would spin both directions.
That's how Professor Nixie just keeps talking over people, and you don't even talk to him.
No, listen to him. You're the one talking over him right now. Listen.
What?
Yes, you're literally talking over him right now. Please listen.
So you brought up what happens when
Parker. For a better video,
Yeah,
I
man.
want you to look up Felix Baumgartner. His edge of space jump from 71,000 feet above the Earth's surface. I want you to look up that video, and then you will see how the horizon from inside the cockpit of his craft that he went to the apparent edge of space. You will see that the horizon rises up to eye level, but his wide angle lens, he admits that he uses a wide angle lens. He admits
Yes, they did.
that, right? But when you look
But I can show you a video of a rocket that goes up to Jim, come up for air. Jim, you're monologuing. You have 2 ears, 1 mouth. Listen twice as much as you talk.
You calm down and listen to people. Let me finish my point.
Yeah, you did finish your point. It's my turn.
No, I didn't finish. You assume
you brought up the video, and now I'm trying to respond to it.
No, hold on. Felix Baumgartner jumped from 71,000 miles, right? Is that his video?
No, that's the ISS, and you can see the curve.
Bro, really? The ISS? Hold on. I don't even want to get into that side of it. Because if the ISS was even what they say it is, we wouldn't have been able to see. Hold on. Is that the whole globe? Is that what we see?
From there, yes, that's what you see.
You do accept that the ISS, they claim to just be in the low Earth orbit, right?
Right. How high up is that, Jim?
In the low Earth
How
orbit,
high up is
globe.
the ISS, Jim?
Hold on. You said the ISS is
how high up is the ISS?
The whole globe from the ISS.
How high up? No, he wasn't seeing the whole globe. He was just seeing the curve. You have to get really far away to see the entire Earth.
You keep shouting over me, Professor. Like I don't know.
Well, that's because you don't stop talking.
Because you wouldn't let me talk.
You're the one who brings these up.
Parker.
And then we try and respond to them, and you move on to a new topic.
We showed you the from stuff from
that
the ISS.
That wasn't the video I asked you to pull up. I asked you to pull up.
I'll pull up the video. I'll pull up the video right now. But that's the one that indicates. You asked for one that indicates curvature.
No,
showed you
that's
one
not
that
what
indicates
I asked.
curvature.
Oh my days, bro! I asked you to pull up a specific video.
You asked that earlier, and now what's the specific video you want me to
Felix Baumgartner edge of space jump. That's all I'm asking.
How do you spell the last name? Baumgartner space jump. There we go.
Yeah, it's the Red Bull jump.
I'm Professor. Would you
I
like?
I literally see curvature in this video.
Okay, now that's a wide angle lens. Keep watching the video. Can you show the live? Keep watching the video, and you will see that when the camera goes into his cockpit, the horizon rises up to eye level. You have to go back to before he jumps, before he makes the jump. Do you see how the horizon goes concave and convex? Is that if that was a physical curve?
I literally still see the curvature.
See, the curve goes straight and it goes convex.
It's not straight. It's just curved.
Bro, stop lying. Stop lying. We literally saw how the curve went convex. See, keep looking at the horizon line, right? Just keep looking at that. See, now it's extra curve.
It turned off, Parker.
It turned off.
Yeah, I know because it's from they're showing a different angle.
Yeah, so
yeah, all of this, none of the rest of it really shows much other than this.
No, watch. Keep watching that. See how the curve, see the horizon line. It keeps changing, convex, concave. It keeps wobbling. Like we can literally.
Well, that's because he's skydiving.
Yeah, it's like, wow, the perspective is changing. It's almost like he's literally spinning.
He admits that he uses a wide angle lens. Look at how he.
Yes, he does.
Is that the curve?
Yes.
Convex, concave, convex.
Oh, this video doesn't prove either. It's a wide angle lens.
Yeah, keep stuttering because you know.
So why did you ask to bring up a video that neither of us claim proves anything?
It proves.
It doesn't prove anything.
Neil deGrasse Tyson said that guy never even saw the curve. He couldn't see the curve. Neil deGrasse Tyson.
No, what he was talking about and what he said, and you want me to quote it, is he's not seeing the curve. the full curvature of the Earth because he's not high enough.
Jim, wait, Jim. Jim, how long did you cry that you got cut off? And like, almost every single time Nixie's talked, you've cut him off. He let you speak.
It's because he talks in such a way that makes it seem like I'm the one cutting off. Like he just speaks so smoothly, and it sounds like I'm the one.
He's so smooth. Nixie is so great. Yeah, you should. Everyone should follow Nixie real quick. By the way, everyone, make sure to follow Nixie
all the time. He's the one.
Everyone, tap the screen, and if you're one of my followers in here, and I know I see a ton of you, please give Parker a follow. He does wonderful debates. He's a great host.
Parker.
Thank you. He can't get gifts, but you can give him subscriptions and check out his bio. So thank you all for tapping the screen.
Go ahead, Jim. What's up?
Yeah, so we just saw that video, right? You saw how the
I don't think that video proves anything. I like the same as Nixie.
No, you didn't.
My opinion as well.
When did you see the horizon from the cockpit from a non-wide angle lens? Did you see it?
Wait. Jim, I don't want to talk about that video. That video is a publicity stunt for Red Bull. Do we want to talk about the Go Fast rocket, which went up to 300,000 feet and used a rectilinear lens, which does not have curvature in it?
Before we go anywhere else, do you accept that Neil deGrasse Tyson, your globe priest?
No, I don't care what Neil deGrasse Tyson says.
Why? Because
let's do the math together.
Because it doesn't go with your claim?
Actually,
no,
Jim.
Because I don't care what he says about that jump.
Professor Nixie, I think you're being very dishonest. You just said Felix Baumgartner saw the curve. And that wasn't.
You know what Neil deGrasse Tyson said, and you're taking his. Do you want to listen to the whole 4 minutes where he also talks about the Earth being a globe?
The video that
do you want to talk about that video and the 4 minutes he talks about the Earth being a globe in that 4 minutes, or do you want to talk about one sentence?
Parker, can you pull up the video?
No, listen to me, Jim. Answer my question.
I actually want you to engage with his comments, please.
Yeah, okay. Let me tell you what Neil deGrasse Tyson said, and then if I'm wrong,
that's Jim. That's not engaging with his comments. What did Nixie just say?
Nixie just said, "Do I want to engage in the full conversation?" Where he further said the Earth is a globe, but that's besides the point. What I'm saying is, in that claim he made, he said at that distance, at 71,000 feet. Where Felix Baumgartner jumped, you cannot see the curve of the Earth. He literally said you cannot.
No, he says you can't see the full curve of the Earth.
He said you cannot see the curve. He said it's flat.
That's what he's referring to. You have to watch the whole thing, not just tag it. But I don't care. I don't care what Neil deGrasse Tyson says, Pumpkin.
Why don't you?
I really don't. I don't care what Neil deGrasse Tyson is. We can measure the curvature of the Earth, and we've done so for over 2,000 years.
Now you're just making claim, appealing to authority.
No, I'm not making a claim. I can bring up Eratosthenes. Do you know who Eratosthenes is?
Hold on. Now we're deflecting.
Do you know who Eratosthenes is?
You just said.
Do you know who Eratosthenes is?
Is this how a conversation works? Parker,
yes, it's give and take.
If I keep saying that,
it's give and take. You keep going over the same point to ad nauseum.
You just said we should watch the Neil deGrasse Tyson video, and now we're jumping.
No, I didn't want to. I don't care.
You said he says the Earth is a globe after that.
So get your mind off your public enemy number one, and let's talk about who your true public enemy number one is. Eratosthenes. Do you know who he was?
I don't even know who he is.
Do you know who Eratosthenes is?
Invented in a history class, and they told you, and you believed it. Let's talk about someone who literally claimed that we cannot see curvature.
That's not what he meant. And I don't care what he said. If you believe everything Neil deGrasse Tyson tells you, Jim?
I do not even believe.
Do you believe everything, Jim? Jim, do you believe everything Neil deGrasse Tyson says?
I do not even believe what he said in that video.
Okay, then we don't need to talk about him.
I watched the video and I saw that you could literally not even see curvature, because when you look into the cockpit of that space of edge jump, if you look into the cockpit, because I think Parker was being dishonest and he didn't show it. If you look at that video, you will see.
How was I being dishonest when Originally,
You see the whole-
neither me or Nixie were claiming that this specifically showed curvature. All right. If you want to talk about what we claimed, right, look at the videos from the ISS, right, that we were mentioning, the literal live streams that you can see
No,
from the
my
ISS,
initial
in
claim.
which indicate curvature.
My initial claim was that you cannot see the curve from 71,000 feet. We pulled up a video of a person jumping from.
No, hold on. First you said no, Jim.
This is crazy.
Jim, no, that's all you do is talk. Stop complaining about not talking, because that's ridiculous. Okay. Jim, your first claim was you asked Parker to bring up a weather balloon video at 50,000 miles, and we both figured out that was 50,000 feet, not 50,000 miles. Second was you asked for that video. Then Parker brought up the ISS. So let's talk about the ISS or the first video, okay?
Let's talk about the video I asked for him to bring up.
Yes, the 50,000 foot balloon.
No, the Felix Baumgartner video.
That was the second video. We've talked about it.
What did we talk about? What was the conclusion?
We concluded that it didn't actually demonstrate anything with curvature, which was never claimed by me or Nixie.
Wait. So was the conclusion that you cannot see the curvature from that height? Or
no, the camera uses a fisheye lens, so we can't use that video. We all agree we can't use that video.
Okay, so like I said, in that same video, there is a clip where the camera.
We don't want to use that video because of the fisheye lens. Move on to there's more videos than one.
Okay.
Maybe one of the ones we've already mentioned, would you like to engage with?
Which one?
ISS.
Can we get to 1 million likes for what Parker's having to go through? Let's get him 1 million likes.
We're almost there, everyone. We're almost there.
But like I said, right? Let's just say at that height, you could see
what height? What height?
At 71,000. How far is the ISS?
No, we're not talking about the Red Bull jump. Stop. Let's talk about the ISS at 250 miles above the surface.
250 miles, right?
Right.
Okay. How far did Elon Musk launch his private car into space?
He launched it all the way to Mars. It's in orbit out near past Mars. It probably doesn't even exist anymore.
The video where he launched that car, if you look at the video, it shows the whole globe. It shows the entire Earth.
Yeah.
Right?
Oh, he's 10,000 miles away from the Earth or more.
And you can see the entire globe.
Yes.
All right. That's crazy. Pull up the video, Parker. Can you pull it up? Can you pull up the video real quick?
What video? And again, you're like specifically not engaging with what we brought up. Are you just admitting that you have nothing at this point?
No, my initial point was not even about that. My initial point was that.
Okay.
My initial point was that we cannot see the curvature from a plane.
Oh my god. Can we see any? So we can see curvature. We just can't see it the context of a plane. Okay, if you accept that we can see curvature, it's just that we can't see it with the plane. Well, then we're still gonna reject your fucking model that it's flat.
What I'm saying is, we cannot see the curvature from the plane. We cannot see it from 71,000 feet. But if you want to go to NASA pictures, which they claim that or NASA pictures that have been modified.
Hold on, Jim. I've got a claim for you. Can you prove the ISS doesn't exist?
Yo, thank you so much, Amanda. I appreciate the $10 cash app. Thank you so much.
Deflect from the argument right now.
Because if the ISS exists, if the ISS exists, then all your claims are false. Can you prove the ISS doesn't exist?
No, if the ISS, it doesn't matter. Like, what? If the ISS exists, hold on. We're talking about.
Can I, if the ISS exists and it's orbiting the Earth, it proves the Earth is a globe. Would you agree with that?
Hypothetically speaking, like I said before, I'm not a flat earther. Hypothetically speaking, if NASA is an organization that wants to lie to the entire world that the Earth is a globe and goes ahead with all these plans and all these projects, what makes you think it will be a credible source to go get information about?
Wait, that's not what Nixie said. Nixie asked you, do you think that if the ISS exists, that it would prove that there's a globe? Because given that we have photo or videos of the ISS, if there was curvature, that would indicate that we're on a globe.
No, it wouldn't.
It wouldn't. So even if the ISS exists, you wouldn't concede the idea that the Earth is a globe.
Yeah, because it's run by NASA, and if we're talking about them trying to hide the truth, that's the Earth is not actually what it is. Then why would they show us something different?
Okay, so Jim, explain to me this. No, Jim, I've explained everything you've brought up. Now it's your turn to explain something to me.
No, I can't explain.
No, Jim, it's your turn. It's your turn. No, Jim, it's your turn. It's your turn, Jim. Explain this to me.
What you're good at. You just keep talking over people and you never let people talk.
Wait, Jim, he wasn't talking. Just let him speak real quick and then he can go.
Okay, Jim, explain this problem to me. I can download an app, and so can you, and it'll tell you based off your latitude and longitude when the ISS will go over your head. And you can, please allow me to finish, and then I'm going to let you explain how this works on your flat Earth.
I didn't say I'm a flat
Earth. And I can then take that coordinates and my telescope, and I have a picture of the ISS going in front of the sun that I took a picture of exactly where it was supposed to be, exactly at the point in time.
Yeah.
So how does that occur on your model?
$80 million a day, and all you could get is a small picture of the ISS
origin in the
flying across. Like, come on, NASA.
Dude, he's not fucking NASA.
Because of its
I know that.
What are you talking about? He is NASA. It's not NASA. It's him. This is literally his picture. He took a picture.
He has a picture.
He does this on live.
That NASA has put in the sky for him to think it's the ISS. That's what he has.
Okay, so how is it Jim, you're not engaging with the fact?
Yeah, that's all you
The
say.
fact is something is 200 Jim, something is 250 miles above the Earth. It looks like the ISS. It goes over our head as though it's traveling at 24,000 miles an hour. How is it that happens on this Earth?
David, thank you for the $10. I appreciate the Venmo. Thank you so much.
Apparently, the ISS is the size of a football field. Let's take this into perspective and first of all hear how ridiculous that sounds. If the ISS is the size of a football field, and then a plane.
All right, I gotta find the picture.
The biggest plane in the world is also the size of a football field, and at cruising altitude, we can barely see a plane. It looks so small. That's just 5,000 feet. And we're talking about the ISS at 250,000 miles, not even feet, miles. And you think you can see it with your naked eye.
So you think the ISS is closer? How do you think it just floats up there? Do they have
that's some gibberish and child's play that NASA is using to fool people.
That's gibberish and child's play. He has a literal picture of it. I've seen this before.
He has a picture of a device that NASA has purported to the sky and made people think it's
how did they put that into the sky?
Yeah, ask them with $80 million a day, they should do better than that. They should they should create some vacuum and put us in it and think this $80 million a day, bro. Come on.
I can't find it. Okay, but everybody who follows my channel has seen it. So you're simply saying you don't know. So just admit you don't know how something is, and I can triangulate its location with other friends because I have friends, and they're 500 miles away, and they get it at the same angle, and I can use triangles to figure out how high it is.
Yes, NASA is just gonna make you all do some small math and.
No, this isn't NASA. This has nothing to do with NASA, other than we can determine that the ISS is where they say it is when they say it's going to be there with the size that it is.
They say who? NASA, right?
Okay.
Yeah.
I can also determine the distance to the moon with a friend, because I actually have friends, and I can actually with a speed square and a straw and a string with a rock, I can determine the distance to the moon within 1% with a friend 1,000 miles away. Why can we triangulate where the moon is, do trigonometry, and get 240,000 miles?
Yep. I want you to just do a small
Audra, thank you so much for the $5. I appreciate it. Thank you so much on Venmo.
Triangulate to me.
You deserve more than that putting up with this.
Triangulate to me. I know you want him to kick me off, but you're just triangulate to me how this small ship.
1 million likes, everybody. Great job. Thank you all so much.
How this small ship is going to go over the physical curve of the Earth, and how this small ship is going to appear to be on the same horizon as this small sun and the small clouds over this guy's head. Triangulate that to me, Professor Nixie. You've been
No, we're going to talk about the moon, because you keep going back to the same diagram that I redrew for you over there and explained it. And then you ran back to your diagram.
Yeah, run away.
So please explain to me, why can't I measure the distance to the moon?
I have 7 points here. We can.
That's nice. Now let's talk about my point. How can we measure the distance to the moon?
We're not going to talk about.
Why can't we measure the distance to the moon?
Numbers you've made up in your
Pumpkin, why can't I measure the distance to the moon? Okay, it's my turn.
We're not going to talk about random numbers you've made up in your
Oh, no, we're not. We're not going to talk about one random number, Pumpkin. I'm going to teach you something.
Let's talk about what everybody can observe. We can all observe.
Yes, that is exactly what we're going to do. You and your friend, if you ever get one, can do this.
We can all observe ships over the horizon, and I want us to talk about that. We're not going to talk about...
We've already talked about it.
Basement, because that's fake, okay? Now let's talk about...
The moon is not fake. We're talking about the moon.
It doesn't make sense on your globe. Let's talk about corpuscular sun rays and how they don't make sense.
Hold on, Jim, you've talked about what you wanted to talk about. It's time, my turn.
No,
it's my turn, Jim.
It's not your turn.
Okay, I have a great idea. We're gonna go 1 minute, Jim. Okay.
Okay.
So Nixie's gonna go for 1 minute. Then Jim, you're gonna go for 1 minute.
Perfect.
Okay, Jim. We have two people on the earth, and you can make it curved or flat. And these people are going to go out at the same time and use their cell phones and a speed square, which is and a plumb bob, and measure where they spot the moon. And this guy's going to, and we know how far apart they are because they're 1,000 miles apart. I'm going to create a triangle, and guess what? We can measure the distance to the moon using that same formula Blitzphd did with the tangent of the angle times the distance. We can determine how far away the moon is. How does that not work?
Does that prove the Earth is a globe? Is that explicit proof of the globe?
It proves the moon is 240,000 miles away. Will you grant me that?
No. Because you made
Okay, then tell me how that math doesn't math.
I'm not going to sit here and tell you how it doesn't math. It doesn't math because it's based off assumptions of a globe.
What's the assumption?
The assumptions of the calculations you did, you must have included some numbers.
The only assumption is we measured the distance between the two observers. That's the only assumption.
Did you measure the curvature between the two people?
Don't care. You can make it flat. You can make it curved. I don't care.
It doesn't matter, right? It doesn't prove it.
It doesn't matter because it's not going to change the calculation, Jim.
Yeah, we shouldn't.
It's a triangle.
We shouldn't talk about it if it's not going to prove the globe, right?
No, it proved the globe. It proves the globe. That's why you're running like you got track shoes on.
Why? How does it prove the globe? How does it be?
Because it proves the moon is 240,000 miles away.
So, does it mean the ground, the globe is curved? I want us to talk about.
Wait. So let's be clear. Fucking trigonometry is wrong. Let's be clear. NASA's wrong. Let's be clear.
No. Let's be clear.
All of these things are wrong, right? But Jim is fucking right. Jim is right. He figured it out. Everyone else is wrong. Jim is fucking right.
Jim, let's be clear. You're being dishonest, and you didn't give my 1 minute. That's the only
I got
thing.
you. Here's 1 minute.
Because let's be clear about that. Good. Now he keeps bringing up things that we are gonna appeal to his authority and believe that he's done some math that we cannot do, and he has sent people from different countries, and he keeps bringing things that we're going to appeal to him. I'm talking about things that we can all see. We can all see corpuscular sun rays. We can all see ships over the horizon. We can all see seasons and sunsets, things we've experienced. Why doesn't he talk about these 7 things? I have 7 topics we can literally talk about that debunks the globe, but he's going to run away from this because he knows that if I talk about this, I'm going to disprove him. If you give us 1 minute, as you're doing right now, Parker, and you let us go through this 7 points of me, if he can convince me on how these things work on the globe, I'll be a glober right now. I'll believe the globe again. But if you cannot explain to me how these 7 things work on the globe, then I'm sorry, but the flat Earth model will make more sense than the globe forever, because that's just what it is. These are my claims, bro. I'm just a lonely guy trying to find out where I live, and these are the 7 things why I don't believe we live on the globe. So, Professor Nixie, I want us to go through this point, and you tell me how these things make sense on the globe without trying to talk about some random number you made of you and your friend about the moon and expect us to just blindly believe what you're saying, right? Let's talk about these things, and let's talk about corpuscular sun rays. I feel like we've talked about it. Let's talk about corpuscular sun rays for a minute, okay? Let's talk about that. I have some interesting questions about that. Let's talk about that.
Okay. Let me know if you want to talk to it. I'm going to do one picture just so you can explain to me why these rays are parallel of corpuscular rays. So if you notice, the corpuscular rays from above show that they are parallel. But if you look at them from below, they converge. Reason why they do that is perspective, what you've been talking about all the time. This is what they look like from above.
Wow.
And this is what they look like with perspective. So when we look at corpuscular rays from airplanes high above, this is what they look like. And when you look at them like this, oh my, that's my photograph. I don't know how that showed up there, but these are corpuscular rays and they spread around the cloud. So what the corpuscular ray is showing you is to the obstruction, not the light source. But we can measure the distance to the sun using this little known thing called geometry. The same way we did the moon, we can use the moon, the Earth, and the sun to figure out it's 93 million miles away.
Perfect.
Good.
Now, can you give
I think we're going about 1 minute 30 seconds. I think we can keep it that. That sounds like a pretty good.
Yeah, that's all right. That's all right.
Go ahead, Jim.
All right. So the picture I'm showing you right here is a picture that I took by myself, and here you can literally see the sun rays coming at an angle, right? The sun rays are coming in at an angle. It comes like as if you can actually draw a triangle from like the source of the rays, right? So what I'm trying to make, the points I'm trying to make right here is, if the sun is actually just 93 million miles away, right? And then we are seeing the sun rays coming at an angle from that distance, you see that it will sound absurd, right? Because the sun rays are supposed to come in parallel. At no point should we see the sun rays coming at an angle from 93 million miles away, right? So this is another picture. We are in the USA. This is how small we are. And this is the sun 93 million miles away. And we're seeing the sun rays coming in from an angle here in the US. Here in the US, the sun is coming at an angle. But this is how far the sun is from us. So you literally see that if the sun is 93 million miles away, this sun, the rays are going to come in from this distance, and there is no case where you're ever going to see it coming at an angle like this. Like, there is literally no way that works on the globe.
Go ahead, Nixie.
There's literally no way.
So I showed you the way it worked on a globe by showing you the angle not from below but from above. If you get far enough away, you will see the lines are all parallel. What you're measuring there is perspective. That perspective would tell you that the sun is merely just above the clouds. Well, if it was just above the clouds, the highest clouds get to about 80,000 feet. So your sun is not, Blitz had you at 180 miles. You now have yourself at 40 miles, maybe 30 miles. If you believe that these are going back to a local sun, that local sun would have to be 30 miles, 20 miles above. That completely destroys your argument.
Okay, that's not even what I'm saying, right? You claiming now, you're talking about perspective, right? But initially, when I was talking about perspective on this topic, you did not even talk about it. You did not address it. Now, I want to ask you this question. That same perspective which you're talking about, would it apply to us if we're looking over a beach, over an horizon? Will that same perspective apply and make things converge at a distance, creating an optical horizon, whereas it's not actually a physical curve? Will that same perspective that you've just claimed you have knowledge about, when you were pretending you didn't have knowledge about, will it create an optical horizon if we're looking over a beach? Will it?
Are you done?
Yeah, I want you to explain to me how.
Okay, so no, they're different phenomenons. You're claiming perspective creates a horizon. That's not what perspective is. This is perspective. And the best way I can demonstrate perspective is which of these balls are bigger? You can't tell. The only way you can tell is to measure it. And this is perspective. And a vanishing point happens with a ball or a point very far away, like parallel train tracks. There's nothing parallel about the horizon. We're talking about corpuscular rays. So way to track you to a different point. I showed you pictures of the corpuscular rays from above that show the lines are parallel.
Yeah. Now it's the same thing.
So please explain the parallel lines of the clouds.
Parker, go back to the 1 minute. I think we're getting out of hand here.
Well, you were still going over his 1 minute, by the way. So, but go for it, Jim.
Oh yeah. So you just said it's due to perspective that we see the ball appears bigger and smaller, right? That's what your claim is, right? So, due to that same perspective you just claimed, right? This boat, will you accept that due to that perspective, these tiny ripples of waves on the foreground are gonna create an illusion to make you think that your finger can act, that the ripples of the wave can cover the boat, like bottom up? Would you accept that? The ripples of the wave will cover the boat bottom up due to perspective, as you just showed in your experiment? Would you accept that and make you believe that the bottom of the boat actually disappeared, whereas it's just due to perspective? Would you accept that? I'm asking you a question.
We're doing minute to minute.
Go ahead, Nixie, you can respond.
Okay, so no, if I'm on the ocean and I'm watching a ship, not a boat. I don't want to talk about boats. I want to talk about ships. When local waves may be obscuring part of it, but if I put a camera on it, even your favorite P9000, it's never going to bring back the bottom of the ship. So we were talking about corpuscular rays. So I'd like to go back and find out from you,
but did you just
why my picture of the corpuscular rays shows them parallel.
Your picture shows the same thing, just from a different angle. It debunks your globe just from a different angle.
It doesn't debunk the globe, but you just admitted they're parallel. Thank you.
No,
thank you.
I didn't admit they're parallel. I didn't admit they're parallel. I showed you this picture. I'm showing you right now.
Amen. You're coming around.
I took this picture. You're just embarrassing yourself. I took this picture myself, right? You can literally see the sun rays coming in from they're coming in. Let me do a diagram because I feel like you're.
No. Explain this, Jim.
That's just
explain this, Jim.
If you take a torch and you point
Do
it,
you see my picture, Jim? At least acknowledge that you see my picture.
those are the shadows of those clouds. That's
corpuscular rays.
Those are shadows from the clouds reflecting off the sun rays and creating shadows from those clouds. Those clouds, the distance between those clouds are parallel. That's why it gives that parallel dome, right? Like those are not the rays. Those are just the shadows, right?
This is if you're looking from the ground, and this is what happens when you look from above. Why do they look different, Jim?
Look, right? The picture I'm showing you actually shows the sun rays, not the shadows of clouds, right? It shows the sun rays coming in parallel, right? You are showing me of shadows.
Jim, do you see the ray right between the two shadows? That's what a corpuscular ray looks like.
It's okay.
Do you see the bright between them?
It's because the clouds are creating a passageway, a parallel passageway.
Right, that's what yours is doing.
No, you can see. I'm not talking about the path, but I'm talking about the angle at which the rays come in, right? Hold on, let me show you a picture. Like I feel like you're just pretending to be dumb right now. The rays come in from an angle like this, right? When you look at my picture, the picture I showed you, the rays come in like this. They come in like this through the cloud.
Okay, so if you did trigonometry, Jim, I'm going to agree. Let's say we agree with you.
No. Jim. Let's say this.
Listen.
Let me finish.
Let me help you.
Let me finish.
Can I help you?
Let me finish my point before you interrupt me. Don't help me. I don't need your help. Now, this are the clouds, and this are the sun rays. Now, the picture I showed you showed the sun rays coming in parallel. That means a sun ray is coming in from this angle, and another sun ray is coming in from this angle, but going this opposite direction, but below the clouds, right? If the sun was 93 million miles away, if these are the clouds, the sun rays should all come in parallel. They should not come in from an angle like this. They should not come in corpuscular. That's the meaning of that word. They should not come in corpuscular. They should come in parallel, because the sun is 93 million miles away, and because it's that far, there is no way that these sun rays are going to come in from like corpuscular. If the sun is 93 million miles away, the sun rays should come in parallel. They should never come in from this angle. They should not come in corpuscular. Just like the picture I showed.
Right here is corpuscular rays, and this is what it looks like from the ground.
Now
this is what it looks like from above. This is what yes, that's called perspective. Now look at your picture. And no, I'm not going to let you run, Jim.
I'm not running.
Look at your picture. Put your picture back up, Jim.
I'm not running.
Tell me how far the sun would have to be away for your corpuscular ray theory. How far away would the sun have to be from your picture?
Watch this.
Let's do the math of where those rays converge. They would converge on the other side of the cloud. So they literally have to be 15 miles up is what your claim is. The sun is 15 miles up. That's what your claim is.
Let's pretend the reason.
No. Let's go with your claim, Pumpkin.
Your claim, right?
So is the sun 15 miles up?
Let me talk. Parker, give us 1 minute again. I think he's rage baiting. He's just angry right now. He's getting emotional. Now
he's angry? What are you talking about?
This is the sun, right?
Wait, Jim. I just want to ask you this question quick. What do you mean by he's angry? Pumpkin.
He's monologuing. If he's talking over me, that means he's mad. He doesn't want me to talk.
I don't think Nixie is mad right now, Pumpkin.
It doesn't matter, bro. Listen to what I'm about to say. This is the sun, right? This is the Earth. 93 million miles away from the sun. It is this small, right? Now you're
okay. Now hold on, Jim. No. I'm not going to let you get away with this.
Statements.
Draw scale. No, Jim. Listen for a minute.
I know it's not.
Jim.
I know.
Listen for a minute.
I know it's not to skill, but let me finish my point.
Then it would be on the other side of the room.
Let me finish.
It would be on the other side of your house.
I know it's not to skill, but let me finish, and then you interrupt me. Then you can talk. Don't interrupt me while I'm talking. Let me finish, Professor Nixie. Thank you. Now, this is the sun, 93 million miles away, right? We're talking about the sun rays coming in at this angle, right? We're talking about the sun rays coming in corpuscular. That's one angle comes in like this, and another angle comes in like this. And this is the surface of the Earth, right? This is the Earth, right? And we're talking about the sun rays coming in from this angle, which theoretically means the sun must be like not that far away, and that's the reason, right? Although
so that's what you're so Jim, stop right there.
No,
how far away is that sun?
Let me finish.
How far away is that sun?
Let me finish, Professor Nixie. Stop being a child. Stop being a child. Be an adult and actually wait for someone to finish before talking. I'm actually surprised your mother didn't teach you this. Like, wait for a person to finish talking before you interrupt, right? So
You mostly did finish, but okay.
Though I do not know the exact distance that this is away from the surface of the Earth, and I will not claim to know, because if I'm doing that, I'm going to be claiming what the sun is. That's a ball of helium gas, which I am personally not sure it is, because I haven't done the experiment to prove that. I'm going to be claiming some properties of the sun, the size of the sun, which I have not done experiments to prove that. But if the sun rays are coming in corpuscular, right, and the sun is 93 million miles away, and the Earth is this small compared to the size of the sun. And then Professor Nixie says the reason why we see this in reality is because of perspective. That is because we are standing over here, and because of the distance of the sun, it converges. The sun rays actually converges 93 million miles away. Now I want you to get this into scale, right? Get this to perspective. The sun is this big and it's this far away, right? If it is due to perspective, that makes us, tiny little us, see in the same country, say this is the USA, in the same country, see the sun rays coming in at this angle. That will mean that perspective, well, let's actually do perspective.
Okay, Jim, wrap it up. You've been 2.5 minutes, Jim.
This is perspective. The rays that come in are supposed to be parallel, because this rays.
He's got a lecture prepared.
These rays that reach the Earth are supposed to be parallel. There is no way that the sun rays are going to come in like this, because if we're actually looking at it from this angle, like it's supposed to spew out into space. Like, it's supposed to spew out into space, and the sun rays that reach the Earth are not supposed to come in from this angle. At USA, we're seeing the sun rays that are going into space coming in corpuscular. That is insane. That is absurd, and that is what he's not going to accept. He understands this perfectly, and I think honest people in the life know this, but he's just going to monologue and talk about some bullshit right now. Go ahead.
Well, I mean, Jim.
Okay, Captain Monologue, thank you. So let's do the math. I know you're afraid of it, but we'll use this same drawing.
Math doesn't prove anything. I can do the math right now, bro. Math doesn't prove anything. It doesn't prove anything.
Wait. He gave you 2 minutes. Now give him 2 minutes.
All right.
All right. So here's your flat Earth. Here's a cloud. Here's the sun, and you drew it right above the clouds. That means that the observer here can see the ray, and the observer here can observe the ray. We can determine the height of the sun. We know the top of the clouds never get much above 70,000 feet. 70,000 feet, roughly divide by 5,000. What does that give us? Well, if we divide 5, that's 1. So what? We're looking at the sun is between 15 and 20 miles high based off your corpuscular ray theory. You said it's 33,000 miles away. Well, if it's 3,000 miles away, those lines would be almost parallel.
He's Jim,
Jim, let him finish. Let him finish, Jim. Let him finish, Jim.
So when we first talked about it, you said the sun was 3,000 miles away. Well, if the sun was 3,000 miles away, these rays would be almost parallel.
Why are you lying, Professor? Like,
wait,
bro,
Jim, let him finish. Let him finish. It's rude to interrupt. Jim, let him finish.
You shouldn't lie and say I said something I didn't say.
Jim, let him finish.
Bro.
Jim, let him finish.
Okay, so the corpuscular ray theory puts the sun at 15 to 20 miles high. When we talked with Dr. Blitz earlier, you said the sun was 3,000 miles away, and he did the horizon math for you, saying it had to be 200 miles away.
Now, first of all, I did not claim the distance of the sun, and I have never claimed the distance of the sun. I just made it clear before you even went on your rant that I cannot claim the distance of the sun, because if I'm going to claim the distance of the sun, I'm going to be assuming what the sun is. I'm going to be assuming the properties of the sun. I'm going to be assuming the size of the sun. And because I'm not assuming, and I don't like assuming, and I've not done experiments to prove what this is, and whether it's actually optical or whether it's actually a physical sun or what it is. What I'm saying is I'm not going to make the positive claim of knowing where the sun, what the distance is, because I don't know the properties and I don't know the size of this sun, right? But I'm telling you for a fact that the sun rays do come in like this. And you said it's due to perspective that we see it in the USA, that we see the sun rays coming like this. And I've showed you how absurd that is. I've showed you how absurd a 93 million miles far away sun is going to appear. Dude, it's never going to appear. These two lines are never going to appear in the US like this, and a person is able to see that. It's never going to appear if we're looking at it from 93 million miles. The sun rays are never going to come in like this from this angle, because this is how absurd it will be if it's due to perspective. That is why I said the sun rays that are coming into that are supposed to reach the earth are supposed to come in parallel. We are never supposed to be able to see a sun ray coming from this angle, but this is what observation shows, and this is what reality shows us, which means that the sun is not what they told us it is. If you are assuming that the sun is a burning ball of hydrogen gas in a vacuum, then saying that the sun is closer and local will be absurd, because it will burn up the entire earth. But because I'm not making it, because that's what we have been fed into and told things about the sun that are not actually what reality shows, right? So I'm not going to make any claim about the distance, and so you should not misrepresent my statements and say I claimed 3,000 miles, because I did not claim that, and stop lying about things I said. If you're being honest. Yep, go ahead with your yes.
Okay. So if the sun is where, hold on, you told me to go ahead. Now listen, don't use your mouth. Okay. So if the sun is where you claim it to be, which is 15 miles above there, then why is it I can drive 6 miles away and the sun now is in the same angle? Doesn't make any sense. Second of all, I can measure the distance to the moon with 2 observers on the Earth. Jim?
Hey, Jim, spawn.
I did not interrupt you once. Stop. So we can measure the distance to the moon with 2 observers on the Earth, 500 miles, 1,000 miles apart, and we can use triangles, basically trigonometry, to measure the distance. Then we can wait till first quarter moon, and if you go outside right now, you'll see first quarter moon, which means the moon is perpendicular to the sun. We know where the sun is, we know where the moon is, and now we have the base of the triangle, which is 240,000 miles away, and that works to 93 million miles away. This was first done 2,200 years ago, and guess what? They were within 1% just using basic geometry from us using radar to bounce off the sun and bounce off the moon.
Are you done? So what he's just done right now is he has just made some claims and called some numbers to make you all think what he's saying is credible, right? And he hasn't even addressed the point I'm making. He has completely glossed over what I said. He's completely glossed over the fact that he just claimed that we see these sun rays coming in corpuscular because of perspective, and now he's claiming that, oh, we did this 2,000 years ago, and we had some triangles that prove this. He is running away from the point I made, saying that if we see from the US, we stand in the US seeing a sun ray coming in corpuscular due to perspective. If we are looking at a 93 million far away sun, the sun rays should never come in from this angle, because this angle of the sun would have already spewed out into space, and the sun rays that reach the earth, they are supposed to be so gigantic, and they are supposed to be parallel. They're not even supposed to be Like this, they're not supposed to be like, address this. Why are you running away talking about 2,000 years ago we proved the globe with some made-up character called Aristosthenes? Address what we observe in reality. Stop deflecting and appealing to authority.
No, I've measured the distance between the Earth and the Moon. I'm not appealing. No, Jim, I did not interrupt you. Please stop. You complain every time I do it. I don't do it to you anymore. Okay? So I'm not appealing to authority. I'm doing the experiment. I'm not making the claim that somebody else told me what the distance to the moon is. I literally show people how to measure it on my channel live. I literally show people the sun, and today they got to see solar flares. And yes, we can predict when the aurora borealis is going to brighten based off solar weather that has happened 2 or 3 days ago. Jim isn't wanting to talk about the solar weather and the predictions of the aurora because that completely destroys anything. And yes, I've addressed corpuscular rays to my heart's content and shown images of them from above. And if the sun was right on top of the clouds, how do I have pictures that high up and the sun is all the way over there? So Jim's drawing doesn't make sense for where that is. So I'd like him to address solar weather and why we can predict radio frequency outages on the Earth based on solar weather and the aurora borealis and the strengthening of aurora borealis based off solar weather.
That has nothing to do. It has nothing to do with what we're talking about right now. You're deflecting. That's what deflection is. When you take a different topic and you try to force it into the conversation without actually finishing the conversation that was on hand. We were talking about the angle of the sun rays, how they come into the earth, right? We talked about it from the globe model, how it doesn't make sense. That 93 million miles away, you will see the angle coming like this. And now you're deflecting into other topics, so we can just run away from this because you don't want to talk about this. Tell me why these angles are going to come due to perspective. Perspective means things converge at a distance, correct? Right. So if this picture that I showed you earlier, right? This picture that I showed you earlier, you see the sun rays coming in at the angle that I'm just showing. I just draw it on my book. If you see the sun rays coming in at that angle, tell me how it is due to perspective that we can be able to see that if the sun is 93 million miles away. And that's this angle that we see the sun in reality from 93 million miles away. This is how there is no way that it's going to come in, and these lines are going to come in and we see it from the US. Like there's no way the sun rays are going to come in like this. Why do we see the sun rays coming from a corpuscular angle if the sun is 93 million miles away and that angle is already spewed into space given the size of the sun and given how far away it is from this tiny earth? Tell me how that works. Now you're going to tell me how, address this point. Don't run away and tell me to talk about different topics. Address this point. If you cannot tell me...
Okay, I'll address it again. Okay.
Then we go to a different topic.
The rays are parallel, and if they're not parallel, they go to the top of the cloud where your sun must be. Therefore, the sun cannot be there because I have pictures of the sun much further away than the cloud tops. We can both do the math of triangulating based off your assumption that the cloud rays...
I can swear right now that on this same live, right? You have mentioned that the sun rays appear to us on Earth like this from this angle due to perspective. I can swear on that. And you've said that.
Yes, and you don't understand perspective.
No, this is perspective.
You've really demonstrated you don't understand what perspective is.
This is Earth. This is the US. This is how we see it. If it's due to perspective, right? From 93 million miles away, that perspective is going to make us still see it parallel no matter where we are on Earth.
No, because you're seeing the rays relative to what's deflecting the rays. What's deflecting the rays?
Oh, now
Jim?
we're going to that, right?
What's deflecting the rays?
I love that.
What's deflecting the rays, Ray?
Nothing.
Jim?
The clouds are not deflecting the rays.
The clouds, thank you.
They are not. I want you to take
Yes, otherwise the sun has to be right behind the clouds, and you said that, and then you talked about, oh, well, I don't know, I'm not making an assumption that what I know about the sun. So let's address what we do know about the sun. And I'm sorry, but you're going to have to address my point once in a while.
Now you want to run away. He's running away.
No, I'm not running away. You're gonna put your track shoes on and not answer my question. I can predict it.
I promise you.
Why is it that I can predict the strength of the aurora borealis before it happens, 2 days beforehand? Why is it I can predict by watching the sun when a solar flare occurs how much radio frequency blockage we will have and where it will be blocking? Why can I do that?
So now, bro, just like why you be muting my mic, bro?
Because you can't be quiet, bro.
Hold on. All right, Parker, you must be honest about this. Let me ask you a question. We were talking about this corpuscular rays and the angle at which they come in. We are not done with this topic, and he wants me to talk about something else. He made a claim that the clouds are deflecting the sun rays. And when I want to address that claim, and he knows I'm going to address that claim to his embarrassment, he's running away and telling me to address different points about the sun. The point we're talking about the sun right now is about the corpuscular rays. He said the clouds are deflecting the rays. That's what I want to absurdly show how he's stupid by saying that, right? If you take the torchlight...
Do you see what's on my screen?
Let me finish.
No, Jim.
The clouds do not...
What is on my screen?
The clouds simply show you the angle at which the rays are coming in. So the clouds are not some kind of shield that are blocking, that are like... It's not like a mirror or something. If you take a mirror and you point it at the sun, it would deflect the sun rays at a different direction. The clouds don't have that property. The clouds simply show you the angle at which the sun rays are coming in. And that's why we see and we know that they come in corpuscular, because the clouds show us that angle. The clouds are not a mirror that deflects, right? So you just failed by saying it deflects the rays. So the clouds simply show us that the sun rays are coming in corpuscular. And if you want to know why they come in corpuscular, Professor Blitz advises you and tells you that, oh, it's because of perspective. Now, that's why I said, if it's due to perspective and the sun is 93 million miles away, the perspective theory that he's proposing will not hold, because the sun's rays would have already spewed into space, and the tiny rays...
Jim, you've said this 100 times already, okay?
And you're running away.
You keep going back to the same point, but you never address my pictures of the clouds.
Yeah, you want me to run away and talk about some random experiments?
No, those are corpuscular rays. You won't address anything other than your drawing that you keep redrawing.
Because you haven't talked about it. You run away from it. How would something come in like
Dude,
this?
he's giving you... I think we're going over the same thing. Jim,
I have 7 points.
Do you want to move to a different point? Because you have we're still on the first one. People are like, Jim is still here, and we're still on the first point of 7, chat.
I have 7 points, and he's just running away from all my points.
No, you don't. You don't debate. You just go back to the original thought, and you never pivot anywhere else. No, you never discuss anything.
You said perspective, and when I want to start talking about perspective, you say, oh, no, me and my friends carried out an experiment of solar...
No. I'll talk about perspective, but you don't want to talk about it mathematically, which can describe what you're seeing.
Because math is... wait. You just want to run into...
You don't believe in math. That may be your first problem.
I believe in math.
That
talks about things that are real.
Problem number 1, Jim. You don't fucking believe in math.
No, I didn't say I don't believe in math. Math is like a language.
Number 1.
Math
is accurate in describing the world.
Math is English, right? If I say a guy is tall.
No, math is not English.
If I say a guy is tall, that's English. If I say a guy is 5 foot tall, that's math.
No, that's not math either. That's unit measurement.
I've calculated how tall it is, so I can use math to describe the boy, because the boy is real, and because I've actually calculated.
So the sun is not real?
That's what it is.
So the sun isn't real in your perspective. The sun is not real.
We're going to make
Pumpkin, I can tell you the sun is real.
if we are going to make assumptions.
Oh my God! Thank you, Simon. I can prove the sun is real.
If we're going to make assumptions, and
I'm not making an assumption. I can prove that the sun is real.
let's talk about something else. I know the sun is real. We all see the sun, right?
Okay, you just said it's not real, so I can't measure it. So is it real and I can measure it, or is it unreal?
Why are you lying?
Can I measure the sun?
Did I say the sun?
Can I measure the sun, Jim? I want a yes or no.
Lie that I said the sun.
Can I measure the sun,
You
Jim?
cannot measure the sun.
Jim,
Why
can I measure the
Why
sun?
did you lie? Why did you lie? By saying I know. I said by saying.
Can I measure the sun?
Why did you lie?
Can I measure the sun,
Why
Jim?
did you lie by saying I made a statement?
No, Jim. Answer something. Stop going back to your script.
You answer. If you want to force.
Can I measure the sun?
Why did you lie about me?
No, I'm not lying about anything. Can I measure the sun?
Did I say the sun is not real? Did I say the sun is not real?
Jim,
You said you can't make any assumptions about it, and I'm trying to debate you on that and say, yes, it is real, and yes, I can measure it.
Exactly. I didn't say.
Can I measure the temperature of the sun?
To measure the temperature of the sun, you're going to assume the distance of the sun.
No, I'm not going to assume the temperature. Jim, don't straw man me. I can measure the temperature of the sun. I don't need to know its distance to know its temperature. Did you know that?
Do you want to talk about?
Do you want me to show you? Hold on. No, we're going to talk about the sun, Jim.
No.
I'm going to teach you something, Jim. Jim, what is this? Jim, no, you're not running away from this.
Measuring
what is this, Jim?
Has nothing
Jim,
measuring the temperature of the sun has nothing to do with.
Jim, you're running away with track shoes.
No,
what is this?
You are running away with track shoes.
No, I'm not. What is this?
You are
Jim,
running away.
What is this?
One question.
You're running away like a scared. You're scared now, Pumpkin. You're very frightened.
Does it prove
you're running away?
You are running away.
No, yes, this will prove the Earth is a globe.
The temperature of the sun proves the Earth.
This will prove the Earth is a globe, and I'll show you how, but you have to engage with me.
Tell me how measuring the temperature of the sun proves the Earth is a ball.
I will, but you have to go for the trip. Like, I've listened to everything you've said, and I've engaged with it. Are you willing to go on this ride with me?
Go ahead and tell me exactly how.
So let me explain how I can measure the temperature. Do you know what this is, Jim? Jim, do you know what this is?
Yeah.
What is it?
Go ahead. See, if you're waiting.
Well, thank you for the $5 on Venmo. Thank you so much.
I'm not gonna engage in anything. If you're gonna ask.
Okay, so now that you just lied in front of everyone. Do you want to take it back and ask me what this is?
If you're going to keep asking me questions like, do you know what 1 + 1 is? Do you know what a shoe is?
Well, do you know what this is?
Make your claim, make your statement and finish your claim.
Oh, okay. So we can look at the black body radiation coming from the sun or my forehead with an infrared thermometer, or I can use a thermometer, a telescope that gives me the temperature of the sun by looking at the black body radiation and determine the surface temperature of the earth, of the sun. So I know the temperature of the sun because I can measure the light coming from the sun tells me the temperature of the sun. I can also determine, based off that, how much energy the sun is delivering to us. If I know its temperature and I know how much energy it's delivering to the earth, I know how far away the sun is. And that equates to 93 million miles. And I didn't use trigonometry to measure that.
How does that prove the earth is a globe?
Because the sun is 93 million miles away. It has to be going around for it to do what it's doing. So if I know the distance to the sun and the moon, I know the earth is a globe.
It has to be going around to do what? To set?
Yes.
To set?
So how would a sun that's 93 million miles away work on flat pancake syrup land, Pumpkin?
That's the whole point, right? You said if the sun,
That's the whole point. You just deflected back. No, Jim. Engage with me, not your drawing. Engage with the temperature. How do we not know the temperature of the sun and the amount of energy? Have you ever seen solar panels, Pumpkin?
Why do you mention like 10 things? We're talking about one thing. And
well, no, we're just talking about the temperature and energy of the sun. Engage with that.
You just said that proves the Earth is a globe, right? You said the sun.
No, you won't engage. You go back to your little drawing.
You said the sun is 93 million.
You know, there's over 1,000 phenomenons that I understand that make the Earth, that prove the Earth is a globe. I've only touched on 3. Would you like some more that'll make your head melt?
I think your head is literally melting right now.
No, because you can't address the temperature of the sun, can you?
Like I said. You made.
Can you touch it? Please go back to the temperature of the sun.
You said the temperature of the sun means.
Right. So tell me how I'm wrong there.
If you would keep quiet and let me talk.
Okay, tell me how I'm wrong about temperature.
Yeah, shut up. This is how people talk, right? When someone is talking, you stay quiet and another person talk. That's how talking works. Maybe you don't know. You said the temperature of the sun gives you an estimation of the distance of the sun and whatever, and that's how we know that the sun is 93 million miles away, and that's how and that's why it does what it does. That means that's why it sets, right? That's why
No, that's not what I said.
That's literally.
So you didn't listen.
That's literally what you said.
No, ask the audience. They'll tell you what I said.
We're going to address that. Because
no, it proves the distance to the sun is 93 million miles away based off temperature and energy delivery.
You expect us to take everything you say with blind faith.
Well, no. You want me to do the math for you? We can sit down and do the math, but you're afraid of the math too. There's more than one way to prove the Earth is a globe, Pumpkin.
Stop talking over me, bro. Stop talking over me. You literally made a claim.
Well, then I want you to address my claims about temperature and energy, not back to your perspective.
Would you stop being a child? Why are you running away from perspective?
No, you're running away from temperature and energy because you don't understand it.
Because everything we see is perspective. If I'm going to explain everything, it's perspective.
No, you're afraid of temperature and energy. Should I go to another topic that you're afraid of?
Mr. Nixie, is perspective real? True. Is it real?
I'm not going to answer your question until you answer mine.
You're running away. Is perspective real?
No, you're running away from mine, Pumpkin.
Is perspective real?
Okay, so everyone in the chat, tap that screen. Let's get Parker up to 1.4 million likes.
1.5 million likes, everyone. If you want to support me, Venmo, Cash App in the bio, as well as you guys can gift Nixie. The only way I can get
all my followers who are following me in here, follow
me too, bro.
Parker. He does amazing debates. He's just a wonderful person, and if you want to learn about all different topics, please give my friend Parker a follow. Hold on, Jim. Thank Parker for having you up here. You probably got you got 1,000. Thank Parker.
Yeah, I'm making it entertaining,
no, he's good.
bro.
He doesn't
come on, we're giving the people entertainment. You all should gift me, bro. Like, come on now.
Well, they have, so you should thank everybody.
That's what I'm saying. Thank everyone. Thank everybody that's out here actually.
Okay, so Jim, can you thank me by answering some of Nixie's questions?
I will answer every Nixie question if Nixie will let me talk, bro. Like, that's all I'm asking.
Okay, so I want you to talk about the energy and temperature of the sun.
Okay, Nixie, I will answer your questions on the energy and temperature of the sun. But before I answer your questions on the temperature of the sun, let us establish what we observe as people about the sun, right?
No, we've already established that 15 times, Pumpkin. I'm tired of going over it with you.
If we're going to talk about the energy and the temperature of the sun, then we are going to need to rely on you to a certain degree, because we are going to believe that you have done some some experiments and you've made up some numbers but that's what we're saying. But what I'm saying is, let us not depend on anybody with anything. Let's talk about what we can all see when we go outside.
No, you're running away from temperature and energy. Let's go back to temperature and energy. We've been over this. Everybody's bored. The audience is bored. Parker's going to fall asleep. The poll says to kick you. So if you go back there, they're probably going to kick you, buddy.
Bro, keep quiet. I'm just saying, this perspective real, because you're running away from perspective. Because, see, perspective is what explains everything that the sun does, everything that the boat does, everything the plane does. Perspective is everything. So
there are 7,000 bored people in here.
If you're going to run away from perspective, then you're running away from the entire argument, bro. You're running away from...
No, we've covered it and you've lost those areas, and we're tired of going back and forth to your same piece of paper.
Yeah, Jim,
I can bring up...
I'm going to be totally real with you. If you got anything else you want to add or talk about?
Hold on, Parker.
Or do you want to go to a new point? Like, I don't know, this whole point you're trying to get here, I think it's not clicking.
I have 7 points, right? But
thank you for the dollar. I appreciate it. Thank you so much.
I have 7 points, right? But I cannot go ahead to make my point if he's not going to be honest and tell me what perspective is. If he's just going to run away from the point.
We've gone over the same thing a million times. I don't think anything's going to change. I think that if you engage in the same thing and expect a different outcome at this point, I think you're going to be qualified by the definition of being insane.
No, I want him to explain to me how time zones, seasons, sunset, airplanes flying against the spin of the earth, the ships going over the horizon, and corpuscular sun rays, and the moon just being a perfect coincidence from a random asteroid in space. These are the points I want.
A perfect coincidence. So, so by that, are you saying that there's a God?
No, I'm not asserting. I'm telling you.
Well, then why does a coincidence matter?
The moon. Do you know how the moon was formed, Parker? Do you know?
Yes.
I don't know.
Do you want me to explain how the moon was formed?
Nixie does. Go for
the hilarious story.
I actually know the scientist personally who helped develop a lot of those theories.
When was he born?
And they're scientific theories. They're not ideas. So was about 4.5 billion years ago. Hold on. I'll bring up a piece of moon rock if everybody in the audience wants to see a piece of moon rock.
Was he alive?
So, no, I've got it.
What?
No, Pumpkin, you're messing
He has a
with the
moon
wrong
rock,
person.
Jim. He has a moon rock, buddy.
What?
I have multiple moon rocks.
I have a moon iPhone right now. This iPhone I'm using is from the moon. I can claim
this is literally from the moon.
How do you know that?
Well,
I'm glad you asked. Now be quiet for a minute. Okay, so no, not because I said so.
Okay, now.
So we can look at the light from the moon and we can put it through a prism. That will tell us the chemical compounds that make up that the light reflected off of. It's called a gas chromatograph. It's called spectroscopy. Jim, you're going to learn, so be quiet.
I know
spectroscopy is used in every criminal trial that has ever had a gas chromatograph. It is accepted across the world by every criminal or every justice. This is how you determine what something is made out of. Well, when we look at the moon meteorites and we look at the light from the moon, they match perfectly. Now, if you get an Earth rock, they don't. They're not exactly the same. Moon rocks and Earth rocks are the most similar rocks in the solar system. They're 99.8% similar, but they're 1/6 as dense as Earth rocks. Wait, the gravity is 1/6 difference. So we can determine that where rocks come from in the solar system based off of their chemical compounds and how they're made up.
You made a claim. You said moon rocks are different from the Earth rocks, right? So where did the moon come from? Explain the creation.
How similar are moon rocks from Earth rocks? I said that too, Jim.
No, you said it's different, right? Where did
yeah, but how similar are they, Jim?
Guys, let me tell you, the Earth.
How similar are they, Jim? I did say it out loud. How similar are they, Jim?
I just let you speak, right?
No, you just misquoted me, Jim.
The moon came from the Earth. That's what they're saying.
No, that's not my claim.
The moon came from the Earth.
No, that's not my claim, Jim.
the Thea, the planet-sized meteoroid that was flying in space, randomly collided with the Earth and formed the moon. So the moon is literally a portion of the Earth that is up there. So how do you tell me?
No, Jim, you got part of the story correct, but you don't have all of it correct. So let me explain.
Tell the story.
So let me explain you how it works.
Yep.
So Thea, a Mars-sized object, not a meteorite. We're talking about a planet, an object the size of Mars hit the Earth at an oblique angle of 38 degrees. It was not a direct impact. It was a glancing blow. And that blew, the Earth's crust completely blew off. Thea's crust completely blew off.
Yeah, we just
now the Earth has two metal cores that we can see when we do earthquake studies and we look at P waves and S waves. We actually have a second core that never completely went into our core. And the moon is thinner on the near side of the moon than the far side of the moon. The moon formed much closer to the Earth. The Earth was a hot ball of mess of lava when that occurred. The moon was. So the far side of the moon cooled faster because its heat was going out into space. Meanwhile, the near side of the moon was closer to the ball of lava. Therefore, this side is thinner, and we can actually see the thin side of the moon and the far side of the moon.
We should just believe all these stories because because why? Why should we believe all these stories? Who saw this happening? How did scientists prove that mass size?
Oh, do you want the proof? Do you want the proof? Can you handle the proof, Pumpkin?
Prove that a mass.
Do you want the proof?
Object collided.
Can you handle the proof, Jim?
5 billion years ago and created the moon that is so intricate in its position that appears.
Come on, Pumpkin.
With the sun.
Can you handle the truth?
This moon that came from a random accident is the same size with.
It wasn't an accident.
It's the same size with the sun due to perspective. This moon creates our tides. This moon that came from a random accident of an asteroid, that asteroid caused our axis.
So you just said the moon creates the tide. That can only happen on a globe Earth. Thank you.
I'm talking about your model right now. I'm not saying it's true. I'm showing how absurd it sounds to say a random accident caused all this to happen.
It's not a random accident.
It's crazy. A flying Mars-sized planet that is assumed by the so-called scientists.
It's not assumed. It's measured.
They all just swallow it. They all just swallow it. No proof of this whatsoever. No physical.
Oh no! We've got proof. We have physical evidence.
5 billion years ago.
We have physical evidence, Jim.
Swallow it. And where are the particles? Why is Earth not like Saturn? Where are all the particles of the crust?
Because Saturn's rings are only 100 million years old, and the moon is 4.5 billion years old.
Wow,
that's a big time difference, Jim.
Yeah.
So, Jim, thanks for monologuing and getting it all wrong. Now, let me give you the physical evidence.
Hold on.
Let me give you the physical evidence.
Wait, Jim, you just spoke for a while. Let Nixie speak real quick.
So when the moon was new,
one-sided, bro. It's so obvious, bro. You're being so one-sided, bro.
Cool, right? You believe the Earth is a fucking pancake.
Shut up! I didn't say I believe that, bro.
Now be quiet.
I'm not a flat earther, by the way. I keep repeating that.
You are a flat earther.
You are a flat earther. You think that's the best model? That's what a flat earther is.
I haven't even talked about their model. Their model makes a lot of sense.
You said that was the first thing you said. You said the first thing you said is I think the flat Earth model is better than the globe Earth model. I think the globe. I can completely debunk the globe Earth model. That's specifically what you said.
No, what you're doing is you're taking the flat Earth and you're fitting it into the globe, like what your picture shows on there, and you claim that you put it.
This is what you believe in, dude.
No,
this is actually what you believe in.
No, see, actually, look at Blitzphd, Gets It on YouTube and Caleb FE right here on TikTok. Nobody believes this shit you're showing on your screen, bro. This is a straw man, big straw man.
This is your belief.
You mean your disciple is Blitzphd, who refuses to debate me because he started to and then he ended it after 3 minutes of he couldn't do a math formula? That guy? Okay.
Go on YouTube, search Blitzphd Gets It and some professor, a real professor, not this clown on this live, and watch the debate. He literally
this clown, but you can't actually debunk anything Nixie's saying.
Nick says isn't talking. He isn't even letting me talk. I just
He is. He's let you talk so much. What are you talking about?
Go on YouTube.
What, Jim? I actually do think that if you've cut him off more than he's cut you off,
and you all are gonna find the real truth about this, bro. Like I'm just a random.
The real truth.
Yeah.
Yeah. So Jim. So stop straw manning a model.
Get them, and I'll have them debate on my platform.
Good.
Get them.
See that.
Hey, Jim,
Get them. Me and Blitz versus Witzit.
Yes.
Yeah. Get them.
Follow
me
me.
and
Follow me back,
Witzit.
Jim. Jim, follow me back and let me know, and I'll literally host the debate.
Blitz got destroyed by Witzit on YouTube.
Blitz,
an average Glober got destroyed by Witzit. I watched the.
No, that was not
I'll
Blitz.
make sure to host it, and we'll see. I'll host it, and we'll see.
Blitz and an average Glober on YouTube.
No, it wasn't Blitz. It was Globy McGlobeface and Tyler, who you're talking about, average Glober. It was not Blitz.
Blitz, I saw a live with Blitz on it. They literally.
Okay, that was a lot. Okay, so the moon formed. Hold on. You've been talking for 8 minutes, Pumpkin.
You too.
All right. Yes. Put pumpkins in the chat if you think Jim is a pumpkin.
If you think
Pumpkins in the
right.
chat, everyone. Pumpkins in the chat.
Pumpkins in the chat for Professor Nick.
All right. So when the moon formed, it was much closer to the Earth. It's the reason the Earth days are slowing down. And when we look at the geologic record in river deltas, the sediments that build up, a day was 8 hours a day when the Earth was 3.8 billion years. And when we look back 2 billion years, a day was 14 hours a day. So as the moon pulls on the Earth's tides,
Jim,
it is slowing down it's slowing down the Earth, and the moon is speeding up and leaving us. And we can actually measure the moon is leaving at about 1.5 days, or 1.5 inches a year. And part of the reason is the tides.
Jim just got flagged. So we're going to go to the next person. It looks like chat did enough of it in order to try and figure that one out. Let me see if... I really hope this guy's a flat earther. I really hope. Wait, Dex, are you a flat earther?
Listen, I've already debated this telescope thumper before. He's on here pushing nothing but lies. Nothing but lies. This telescope thumper.
I don't remember you.
Listen, buddy, I'll wipe my ass with your fucking degree. I will wipe my ass with your degree. You tell
Okay, Pumpkin, let's talk about some proof.
The amount of faith it takes to believe the bullshit you just spewed.
No. I want to hear some of your evidence, not your incredulity.
You should be teaching a class on faith if you believe that garbage you just spewed on here. Garbage. Just like when I debated.
So you don't believe in geometry either?
You know what he brought to you? Hey.
So are you afraid of geometry?
Wait a minute. You know what?
Are you afraid of geometry?
You know what another scientist brought to the argument? He was trying to prove evolution. A fucking fruit fly. A fruit fly is what you guys tried to use.
Yeah,
to prove
speciation amongst fruit flies.
My ass with your fucking theories.
Dude, that's actually like the evidence of speciation.
The only thing I see that's round is that moon head that you got on your shoulders.
Okay.
Fucking telescope thumpers.
Hey, Des, can you explain to me sunsets, please?
Yeah, the sun goes around the Earth. Right, just like
you just proved the Earth is a globe. Thank you, Pumpkin.
Let me tell you something. The only thing that you guys try to prove this round Earth because you want to disprove the Bible. Parker, you've been warned already.
Why is it?
Wait a minute, sir. You can think the Earth is spherical and still believe in the Bible.
You're not fooling anybody, sir.
Wait, Des.
Well, 99% of Christians believe in a globe Earth and Jesus. It's totally possible.
All your bullshit math equations amount to a lump of shit. The amount of faith it takes to believe that garbage is embarrassing. Embarrassing, sir. I'm embarrassed for you.
Why don't you turn on your cam?
Just like the Bible says that in their intelligence,
Des, turn your camera on.
They become
Turn your cam on, Des.
What'd you say?
Turn your camera
Turn
on.
on your cam. I want to see who I'm talking to.
Handsome I am. I already showed you how handsome I am.
Yeah. You're not that brave.
Look at my
So
picture.
you're just hiding behind a
Wish
screen.
you look like me. Evolution didn't work
okay.
in your
Show us,
favor,
Des,
sir.
Des,
Evolution didn't work in your favor.
Des, come on, show us.
No,
Why not?
I'm handsome.
That's
enough.
what I thought.
Listen to me, sir. All that bullshit you're spewing means nothing to me. I will literally wipe my ass with you and all your evolution
we are
bullshit.
not
Also,
hold up.
it's nothing. It is nothing. You guys bring a fucking fruit fly to the argument to prove evolution.
Yes. That's actually evidence of speciation.
This other fucking
Des, can you hold up?
bullshit.
Des, I want you to simmer down for a second, and I want you to listen, okay? Fruit flies, the speciation amongst fruit flies is absolutely evidence of speciation. That's clearly evidence.
That's what you bring to prove evolution. A fucking fruit fly.
It's the part of the proofs of evolution, which would include speciation.
Come on, you're smarter than that, Parker.
Speciation. Hold up. Speciation.
You're smarter than that, Parker.
Speciation.
Parker,
Speciation.
you are smarter than that, Parker. Stop it, dude.
So speciation is an aspect of evolution. So just the proof
in this argument.
So just the proof of speciation doesn't actually necessarily prove all of evolution. It's just one of the proofs of evolution, right? Secondly, if you want to relate to sunsets, which is what I was originally asking you, how do you explain sunsets under a flat Earth model, right? Because under your model, the sun is supposed to get smaller when it does not.
Listen, buddy. Fly argument doesn't mean you. You're telling me you guys are set to prove evolution using a fruit fly. Parker, I thought you.
We can also use 100% of the DNA evidence and 100% of the fossil evidence, but there is that.
Quiet down, pumpkin. Parker.
Okay, pumpkin. Oh, you're so brave. You're not willing to put these comments with your face on cam, are you?
Parker,
okay.
I thought you were smarter than this, Parker. You're bringing up
the gaslighting is real.
To this argument.
Hey, Des,
are you serious, Parker?
This conversation's not about
evolution.
Come on,
buddy, listen.
Listen,
your mom is praying
this
for you, Parker.
This is about the flat Earth.
To refute this bullshit.
Des, hold up, man. This is about the flat Earth. It's not about evolution. I'll continue to talk to you about evolution on another day if you'd like. It doesn't seem like you're even engaging with that, right? But would you like to stop thumping on evolution and instead thump on the flat Earth?
As long as this guy stops thumping his bullshit lies.
He's not lying.
He's lying. Oh, he's lying.
Prove something that I'm lying about, please.
Mental gymnastics you gotta jump through to believe.
I didn't do any mental gymnastics, but you haven't brought anything to the table but colorful metaphors and the inability to do a rational thought.
Gymnastics, you got nothing inside that round head. Full of hot air, useless fucking information. There is a creator that made everything.
Why are you so upset?
10 times an explosion.
So you're so upset, and if you are religious, you're not showing the fruits of the Spirit, are you?
Get quiet down, pumpkin. No one's talking to you. Jesus is Lord.
Okay.
Your bullshit doesn't mean nothing. Quiet down.
Who would Jesus rather listen to? Somebody insulting everyone or somebody explaining the beauty of creation?
Wait, just to clarify. Wait, hold up. Just to clarify. Jesus would believe the earth is flat?
Listen, the Bible says what it says.
Jesus would be a flat earther?
Listen, the Bible says what it says, right? And the Bible
and there's more references like in the book of Job where they talk about a round horizon. Did you not read the book of Job? Sir, you didn't read the book of Job?
You have been deceived.
You're the one that may be deceived because you haven't read the Bible.
Do you believe in God?
I'm just talking about the curvature of the earth and where it's mentioned in the Bible. Did you not know that it's not mentioned? It's mentioned in the Bible.
Yes or no? Answer the
no, Des. Answer my question. The book of Job, does it not say the horizon is curved?
Do you? Do you believe in a creator?
You have yet to answer any of my questions, pumpkin.
It's a simple yes or no. Do you?
Hey, Des. He doesn't. He doesn't.
You don't?
No,
not to my knowledge.
I gotta go.
Okay. You literally have come on my live how many times, Des? What is this guy doing, dude? We're gonna go to the next individual. Only send a guest request if you disagree. If you think that the Earth is flat, send a guest request right now. Please only send a
Thanks
guest
for
request.
having me up, Parker.
You think the Earth
and
is flat?
everybody tap that screen. Parker can't get gifts. He's got an issue with TikTok, so you can do subscriptions, or he has options in his bio.
Okay, I appreciate it, man. Appreciate it. Yo, what's up? How old are you?
Hello.
How old are you?
Hello.
So I'm gonna show my face.
Are you driving?
No, I'm not.
Okay. Do you think the Earth is flat?
So I've been for this. Oh my gosh, I've been seeing this so much lately and whatnot. For the Earth is flat. I'm not for this theory whatsoever.
So you don't think it's flat?
No, I don't think it's flat.
All right, I am just looking for people who disagree. Appreciate coming up. We're gonna go to the next individual quick. Please only send a guest request if you think that the Earth is flat. Everyone, we are just looking for some debates. Yo, what's up? How old are you?
I'm
Hello?
20.
Yeah.
I'm
Do you think that the
20,
Earth is flat?
Now, you should just meet at one location and fight yourself. Because I'm just sick and tired of this argument online. And
Do you think that? So you don't think the Earth is flat?
I don't think the earth is flat, bro.
All right, appreciate you coming up. We're gonna go to the next individual. Please only send a guest request if you do disagree. Again, everyone, we are just looking for some debates. All right, let's see if we can get this individual up here. Doesn't seem like this person's getting accepted. Let me try the next real quick, everyone. Yeah, they could just swipe away. I don't understand. Yo, what's up? How old are you?
28.
For sure. Do you think the Earth is flat?
No, I don't.
All right, we are just looking for people who think it's flat. Appreciate you coming up. Let's go on to the next individual quick. Please only send a guest request if you disagree. Jim is still in the guest box. Yo, what's up? How old are you? How old are you? All right, let's go to the next individual. Jim, you got flagged, man. You got flagged, Jim. Yo, what's up? How old are you?
I'm 55.
For sure. Do you think the Earth is flat?
Yes.
Why so?
Why so? Well, if you go up to Michigan City and look at Chicago and you have real good binoculars, now technically you should only be able to see like the top of the Sears Tower, but you can actually see more than what you should if the Earth is round. So how is that?
How I would have to see where you were, what your height was on the other side, because as we talk about, the higher up you go, the more you'll see. So you to do that type of work, you need
it's all east of Michigan Lake.
Okay,
you say Michigan Lake, and you're at the beach on Michigan Lake, which is lake level pretty much. Then if you have
but 6 feet makes a big difference. So it depends on what there's a thing called the Earth Curve Calculator where you can put that in and it'll tell you how much you can see. But why is it that you can't see New York? Why is it you can't see something 700 miles away or 1,000 miles away? And why is it when you drive towards a mountain or Chicago, the top of the Sears Tower is the first thing you see over the horizon, and then the entire city rises up? What's blocking the bigger part of the city?
Yo, David, thank you so much for the $15 on Cash App. Thank you so much, David.
Yeah, I have no idea on that one. So.
See, and that's the way you can see the curvature of the Earth is driving towards a mountain or a city. You always see the highest part first. And I'm going to bring out my sample mountain, okay? Well, the bigger part of the mountain is the bottom. Would you agree with me, Mark?
Yeah. Yep.
The smaller part is up here. You see this little part like this, and I'm going to do this. Do you see the little part of the mountain? But as you drive forward, you get to see the entire mountain. It doesn't appear over the horizon like this, which is what a flat Earth would say. You see it being blocked, and then the closer you get, the bigger it is.
I don't know. I have to try that out when I go back to the mountains.
Yep.
Yeah.
That's
Yeah,
the best way to determine.
Also, as it relates to seeing a sunset, right? It's something that Nixie said many times. If you have like a drone, right, after the sun sets, right, you can attach a camera to a drone, make the drone go up like a few hundred feet, and you're gonna see the sun again.
You can also do it with the Sears Tower in Chicago. You can get on the elevator, go all the way up to the top after the sun sets, and you'll go up to the top of the building and the sun will not have set at the top of the building.
Okay. All right. Well,
And actually in the Middle East, they have buildings during Ramadan where because they can't serve the meal until the sun sets, they have to set it on different floors at different times based on when the sun sets at different floors.
okay. I was just listening to different theories and stuff like that. One of my best friends is a flat earther. So he got me thinking and doing some tests. That's why when I was up in Michigan City, I kind of did with the binoculars and stuff. So yeah, it was just a wondering thing. So I appreciate the invite.
For sure, appreciate coming up. Thank you so much. Let's go on to the next individual. Only send a guest request if you do disagree. Again, everyone, we are just looking for some debates. Let's try the next person real quick, everyone. We'll probably do this here for like the next little bit, y'all. However long Nixie can stay on. Are you good? I know I stay on for a really long time. Typically,
I'm good for a while, Parker.
All right, for sure.
It's a pleasure. Thank you.
Of course, man.
Yep.
Yo, what's up? How old are you?
32.
32?
Yep.
For sure. Do you think that the Earth is flat?
I believe Earth is flat.
Why so?
Yeah. The reason why I believe the Earth is flat, because when they say the Earth is a spherical shape, it's like a ball. So that to me that doesn't make sense, because if the Earth is spherical in shape, because no scientists actually have traveled to see the end of the Earth, and actually I don't have any valid argument against this point. Sorry.
Okay, all right. Appreciate you coming up. Thank you. All right, let's go to the next individual. Please only send a guest request if you disagree, everyone. We are just looking for some debates. Let's try the next person real quick. I guess they don't have a valid argument. If you want to support me, Venmo, Cash App in the bio. If you want to support Nixie as well, you can gift through the app, everyone. Or if you have Venmo, do you have Venmo and Cash App in your bio?
No, I accept gifts or subscriptions on my own channel, but we're here to support Parker tonight. This is his channel. Thank you for having me up, and thank you all for the gifts.
Yo, what's up? Oh, okay, they left.
And all the gifts I get are going to Eclipse glasses for Denver Public Schools and Aurora Public Schools for the eclipse in April. I will donate them all the proceeds to that.
Yo, what's up? Are you driving? Okay, they're not even there. All right, we're gonna try the next individual real quick. Please only send a guest request if you disagree, y'all. Again, we are just looking for some debates. Yo, what's up? How old are you? Hello? All right. Sometimes it does take a second to get people up here. In the meantime, everyone. I mean, this is a Flat Earth Live, so actually I've literally no clue how long it will take. But we will be able to get someone here real quick. Yo, what's up? How old are you?
42.
For sure. Do you think the Earth is flat?
Is the Earth flat?
Yeah. Do you think the Earth is flat?
No.
All right. Appreciate you coming up. Thank you so much. We're going to go on to the next individual. All right. Only send a guest request if you do disagree, everyone. Again, we're just looking for some debates. Please only send a guest request if you think the Earth is flat. Bro honestly doesn't know what reality he's in. Let's be real. Let's be real. Bro lost. He's like watching interdimensional cable. All right. Yeah.
So to all my followers who followed me in and follow Parker, he does a lot of debates, not just on this, and he does a lot of really great debates. Please give him a follow. Thank you guys so much.
Yeah. How old are you?
Hey, I'm 42.
For sure. Do you think the Earth is flat?
Yeah, the earth is flat, you know. It looks
Why
like
is
your
that?
forehead. Hi, Professor. Keep the fire burning. You're doing a great job.
Thank you.
Yeah,
So you think the Earth is flat like my forehead?
No, like Parker's forehead. Have a nice day, man. Good night.
All right, we're gonna go to the next individual. Only is the guest request. If you disagree, y'all, we are just looking for some debates.
Hello?
Yeah, what's up? How old are you?
Hello.
I am 35.
For sure. Do you think that the Earth is flat?
It's very flat.
Why do you think it's flat?
So if I go to the mall in Beverly Hills and I go from Spencer's to Hot Topic and I go in a straight line.
I'm getting caps. I'm getting trolling vibes. All right, we're gonna go to the next individual real quick. Did you talk to this person?
Who goes to Spencer's anymore?
I think this person only talked to Blitz. So I don't know if it adds them. We might be able to get them to talk to you. If not, we will just go to the next individual. Okay, it didn't connect them. We'll try the next real quick, everyone. If not, we might just have to end it for today and try a different time, everyone, of course. So maybe
you can always do the Big Bang too if you ever want to do that topic.
Oh yeah, I do have to do that sometime. Yo, what's up? How old are you? I have a new one that's like pretty interesting. It's like, how do you know Jesus isn't Satan? So I'm gonna be running that one probably here pretty soon.
That's a good one.
Please do this topic again. Oh, we absolutely will.
W Parker in the chat.
Appreciate it. Oh, look who's back. He hasn't talked to heathens. What happened?
What's up, heathens? Did you just say the Big Bang Theory? Fuck.
Yeah.
Fuck, buddy. So here, let me ask you a very simple question. Okay?
Certainly.
I go to your shack, your chateau, whatever you have. I play C4 all along. I blow that shit up. When I walk back into your house, am I gonna find the Swiss timepiece perfectly working and function? A skeleton?
Well, you just described an explosion, not an expansion. So thank you for using a false equivalent.
Wait a minute. Is that what I'm gonna find?
No, you're going to find yourself arrested for doing that, but that's a different story.
You would agree.
So
you would agree.
No, Des, let me talk.
Wait a minute.
It's your turn to be quiet.
Right? It's a ridiculous concept, right?
No, because you don't even know what you're talking about.
No, listen, it is a
No, Pumpkin, you don't know what you're talking about.
An explosion caused.
It's not an explosion.
Perfect harmony.
It's a name. So Des, it's an expansion.
Listen, buddy, it's Desomis. It's Desomis.
It's not an explosion. Even though you read the title and none of the content, you didn't get what the movie was about.
Listen.
Okay.
So 10 out of 10 times an explosion causes destruction. But in your guys'
it's not an explosion,
so you're talking
Pumpkin.
about the expansion of the universe. That's
so it's just like the Bible that you didn't read. You didn't read about the Big Bang.
Are you sure I didn't read it? Are you sure I didn't read it? Oh yeah.
Yep.
How are you so sure I didn't read it?
Because there's more references about the curvature of the earth in the book of Job.
There's what?
And you can't quote any of those, can you?
What did you just say? There's what?
Quotes about the curvature of the earth in the book of Job.
Give it to me.
No, you go read your book.
Give it to me.
I don't have to give it to you. I gave you the book. You don't have your book memorized?
Sir, you are a heathen. You are a
no, I'm not.
Heathen, sir.
Wait, Des, what are the first? What are the gospels?
Lies.
Hey, what are the books? What are the books of the gospel?
How many authors in the book? How many authors wrote the Bible? Tell me.
How many books of the gospel?
We don't know.
I'll tell you.
No, that's
66.
actually right. We don't know.
How many books are in the Bible?
No, actually, we don't know if it's 66.
40. 66, 40.
Wait. So Paul
I just taught you something.
No, you didn't. JK, I appreciate the subscription. Thank you so much. So Paul wrote multiple books of the Bible. So saying that 66 books was written by 66 different authors is something that you wouldn't even accept. If you accept
books, 40 authors.
Corinthians, Romans, are those both?
66 books, 40 authors, Parker.
Who wrote the book of Mark?
Okay.
Mark.
Who wrote the book of Mark?
Mark.
No.
No,
It actually says that we don't know who wrote
Buddy,
it.
stop
So you
it,
don't
buddy.
you didn't even read that
Buddy,
part of the book of Mark.
Stop it.
Thank you for subscribing.
Listen, buddy,
That's the best way to support
I
Parker.
know that the thought of Jesus offends you and
No,
all
it
that
doesn't.
empty hollow head you got. You have so much useless knowledge.
You're projecting your
There's a God.
fears really
Listen,
well.
buddy, and all
Are you
that
upset? Are you
information that you
disrupting
hold in
right
your
now?
head,
Because you sound
believe
like
there's
you
no
don't
God.
have
Listen,
much
buddy,
faith.
You're not smart enough to believe there's a God. Think about that. You think this is an accident. You think all of this is an accident. You have to be one
Thank you
of
for
the
subscription.
dumbest people I have ever come across to believe that this was caused by an accident.
No,
Thank you for the
I don't
subscription. I
claim
appreciate
it was
it.
caused by an accident. That's you.
As the day
Wait,
is
wait,
long.
an accident.
This is not
implies-
an accident.
Hold up,
Stop, man.
Des, please stop talking.
This is not an accident. You have to be one delusional individual to.
Okay, so an accident implies that there was some sort of intention otherwise, and that it didn't like meet with respect to that intention. Appreciate the subscription. Thank you so much.
Parker,
But we don't
stop
think that
it,
there
dude.
was like
You
an
know
original
better,
intention.
Parker. You know better than that.
Go ahead and Google your information.
I didn't Google anything.
No, I'm talking to this guy over here.
No, I'm responding while
got
you're
nothing. Stop-
monologuing.
Look, I'd advise you to stop pushing your lies on here. Okay, Parker, I know you're young and you don't have a lot of life experience, but this guy right here is a fraud pushing lies.
No, he's not.
Yes, he is.
You're
Yes,
a
he is.
fraud,
He's
Des.
a fraud. He's a fraud. I
No,
just asked
the only
him
one
a
that's a
que-
fraud is you.
He's a fraud, dude. He's a fraud. The mental gymnastics you got to jump to believe this crock of garbage.
No, you're the one jumping. You're the one really triggered by all this. How did we
Jamal, I appreciate
trigger
the
you
subscription.
so
Thank you so much.
badly?
Listen, you have more faith than I do if you believe that garbage.
That B, I appreciate the subscription.
You
Thank you
have
so much.
more faith than me. The amount of faith it takes to believe this garbage you're spewing is amazing.
You don't even understand. You don't even know what we're talking about.
Listen, sir, I
you
know
can't
exactly
even
what you're talking
describe
about.
it
I know
accurately.
exactly what you're talking
You
about.
don't.
The amount
You think it's an explosion of
Listen,
something of
write a
some
book-
kind.
Write a book on faith. You have more faith than me. If you believe that.
Have you ever looked through a telescope, Des?
Listen, telescope.
Have you ever looked through a telescope?
Yes, I do. Actually, I have one.
Okay, what do you have?
Listen, sir.
What do you have?
The amount of
Kayla, I appreciate the subscription. Thank you so much.
You should be ashamed.
What do you
of
have,
yourself.
Des?
Listen,
What do you have, Des?
That wisdom that God gave you to.
Or did you lie about that
Because
before
the
your
hoops you gotta
God?
jump through to push this garbage and get people to actually.
So
fucking
you
do it
lied about
is
having a
amazing.
telescope.
What'd you say?
And you're cussing and you're using
Nobody's cussing.
your
Who's
Lord's
cussing?
name in vain.
Who's cussing?
You.
Who's cussing? I haven't said one cuss.
You did.
Oh, suddenly
Yes, you
now
did.
I'm not- wait. So suddenly now I'm not a Christian because now it offends your ears, right? Is that what you're telling me?
No, you're
Suddenly now-
not
wait,
you're not
suddenly now
following
you're
your
saying
own
it's right?
belief system.
Sir, stop spreading your lies. You're spreading lies. And you're dragging Parker along
Appreciate the
with you.
subscription. Thank you so much, Blend.
Okay? You know as well as I do, this is not by accident. This is not an accident. What we're
Nobody's
It is
claiming it's by
perfectly
accident.
designed by
Only
the
you.
Creator.
You're the one
don't spread your
claiming
lies.
it's an
Listen,
accident.
Listen, sir. You're spreading lies.
No,
This
I'm
is
not.
This is not by.
Tell me
by
what I'm
chance.
lying about,
This is not
Pumpkin.
an accident. This was not.
No,
by
Des,
slogan. We get involved with
Des.
animals.
Des,
We are
the only
created
thing that
in
was
the
an
image of
accident was
God.
you, right?
We are created in
Nothing
the
else we're
image of
talking about
God.
here is an accident because there wasn't
Jesus
some
is
type of
Lord, and
intention.
every one of you will bow, including Professor Nick C, with this useless garbage. Lies.
Oh, thank you.
You are pushing
Yeah, I
lies.
appreciate the subscription. Thank you so much, Danielle.
I'm here to
Appreciate it.
refute your garbage.
Okay,
Des.
the garbage that built your
gotta
cell
go.
phone that you're denouncing the science of your cell
Oh,
phone.
he just left. He literally just left. Oh my gosh. Yeah, literally
That was-
the only
that was
was
good.
actually wild. All right, we'll try to get someone else up here. Everyone, only send a guest request if you disagree. We are just looking for some debates. We're gonna get access to the sub only chat. Subscribe if you haven't already. Yo, what's up? How old are you?
28. Dang, so there's 29 people. Give me one second.
Hello? Okay, I think they're just not, they're like doing something else. We're gonna go to the next individual. Only send a guest request if you disagree. Again, everyone, we are just looking for some debates. That was painful. It always is. It always is. Honestly, that's just today, to be honest. We're gonna see if we can get someone up here, though. Please, again, only send a guest request. If you think the earth is flat, everyone, we're gonna get some people up here very, very soon, y'all. Yo, what's up? How old are you? Hello? Des can't be real. I actually originally thought that he was like a troll, but He's not. He's like literally not. He literally always is like that. Okay, it's not accepting that person either. Let me try the next real quick. Again, everyone, please only send a guest request if you do disagree. Yeah, maybe it's this topic. Yo, what's up? How old are you?
Hey, how you guys doing?
Yeah. Do you think that the Earth is flat?
I do. I am a flat earther. I do believe the Earth is flat.
Why so?
I believe every sense that we have tells us the Earth is flat. I believe our eyes tell us we're flat. Motion tells us we're flat. I believe physics tells us we're flat. I believe science tells us we're flat.
Riley, I appreciate the subscription. Thank you so much. Okay, can you explain sunsets to us?
Sure. Visibly, I think it would be easier. Let me grab my laptop real quick, if you don't mind. I'll turn my camera on. I can show you maybe some visuals.
For sure, that'd be great.
I believe the sun, the moon, the stars, I believe they rotate around us, not vice versa. I don't believe.
Now, Brian, do you know who came up with the geocentric model?
Who came up with it?
Yeah.
I believe ancient civilizations, all the way from the beginning, were believing the Earth is flat.
No, they didn't believe the Earth was flat, but they did believe the Earth was the center of the universe. Ptolemy was the first one who came up with a model of that. Alex, 10 subscriptions.
Yo, Alex, thank you for the 10 subs. Can we get a fucking W Alex in chat real quick? W Alex in chat. Thank you so much.
And when was this polymer guy, Ptolemy?
The Ptolemy was about 150, 200 BC, ancient Greek. And he actually drew the Earth as a globe. And he drew all the planets and the sun as a globe. But because of Aristotle, most people thought the Earth had to be the center of the universe. But they did have all the objects going around in orbits. So the geocentric model is not a flat Earth model. It is a Earth-centered model.
Sure, geocentric, absolutely. Earth in the center, or the heliocentric
Amber,
model.
think of the subscription.
The sun in the center, correct.
Correct.
I believe personally, I mean, I hold to the term geocentric model, but I believe we live on a flat, stationary plane.
It's me, I appreciate the subscription.
With a dome above our heads, just like I'm a firm believer in the Bible. I believe the Bible teaches us in a flat Earth.
So the Bible says it's a firmament, and the firmament in Hebrew means expanse. Doesn't mean dome.
Actually,
it means
solid
expanse.
That's incorrect. The word is raka in the Greek, which means solid dome.
No, it's not in Greek. It's in Hebrew. The Old Testament was written in Hebrew and Aramaic. It was not written in Greek. The New Testament was written in Greek.
Sure, I agree. The word raka in Hebrew means solid dome. Let's pull that up real quick.
Yo, Elisa, I appreciate the subscription. Thank you so much. In the meantime, everyone, keep tapping that screen. Let's try to get to 2 million likes, everyone. We're about 400,000 away from 200,000. If you want to support me.
So, Brian, go ahead, Parker.
No, go ahead.
So, Brian, so if we're in a dome, is that because you think air pressure can only happen in a container?
That's what science tells us, no?
Right, but science would also tell you that in a container, what will all air pressure do? Pressure of a gas do in a container?
Go ahead.
It will equalize. We don't have equal pressure. I mean, look at the Denver Broncos. They have home field advantage because they're a mile high and there's less air.
W Broncos in the chat. W Broncos across the board. The Broncos are the best team in the league. I appreciate the subscription. Thank you so much. Again, spam W Denver Broncos. Definitely not biased towards the Broncos.
So the air pressure is a gradient. You go down to sea level, there's more air pressure than at the top of Mount Everest. And the way airplanes determine their altitude is based off the barometric pressure. So you couldn't be in a container and have a pressure gradient.
Thank you for the subscription. Appreciate it.
Well, I believe, speaking about, I'm not sure, exactly, I'm not familiar exactly with what you're saying, not be able to have that pressure gradient. But speaking about airplanes, I believe pilots, and many pilots have made this statement.
Thank you for the subscription.
I'm a pilot, just so you know. I have a instrument rating.
Good for you. Good for you. And whenever you're up in the air, X amount of feet up in the air, and you're traveling, do you ever tip the nose of the plane to accommodate for the curvature of the earth?
No, but I don't tip it up either unless my altitude changes. Because what you do as a pilot is, hold on, Brian, I'm a pilot. I actually know. You keep it at the same altitude. So you're always making minor adjustments up and down because you're keeping at a pressure gradient.
Subscription.
I believe the gyroscope is something different, though. The gyroscopes
all drift by 15 degrees an hour. So do you want to talk about gyroscopes? Because the Earth also spins at 15 degrees an hour. So why would all gyroscopes drift by 15 degrees an hour?
I got my camera here, guys. Let me switch it around here. How do I switch it?
You should be able to click modify. Oh, there you go. You got it.
Did I switch it?
Yeah,
I did.
As you have to click save.
Save. Okay.
There you go.
So your first question, my friend, was how is sunsets, correct? First and foremost, I believe this is just a rough model, but obviously here's your sun, here's your moon. Your sun and your moon both rotate around the earth at the same time. I'm sure you guys have heard it. So instead of the sun and the moon is both rotating around us. When the sun is here, this part of the earth is lit, and vice versa. Eventually, in 12 hours, the sun will be here and the moon will be here.
Okay, so why is it when it's December 21st in the Northern Hemisphere, there's no light up at the North Pole? It's and above the Arctic Circle. And then 6 months later, it's the other way around.
Right. So during the winter solstice, right, the sun is going to be traveling a much greater distance. It's going to be traveling because it's not just sitting in this one spot. So during the winter solstice, the sun is out here at the outer edge, right? Summer solstice, the sun is going to be closer here to the center.
Let me destroy that for you. Mm-hmm. It would have to be traveling further, wouldn't it? Have to be traveling, the outer circle would be greater than the inner circle, right?
Sure.
In distance, but the sun always travels through the sky at the exact same period of time, 15 degrees an hour. Sure. So it can't be changing speeds.
Sure.
So it couldn't be traveling a bigger arc, could it?
More daylight.
No, but it always travels across the sky at 15 degrees an hour.
So how do we get the 3 months of daylight in Alaska?
Well, I'm talking about your model that doesn't work on it would have to travel at different speeds, but it doesn't. Now, if you want me to talk about our model, I'm perfectly willing to, but your model, the sun would have to travel at different speeds, but we don't observe that the sun travels at different speeds.
I don't believe it does. I don't think it has to travel at different speeds. I believe it's always the same speed.
Basic physics. You just said it had to go around a bigger circle in 24 hours or a smaller circle in 24 hours. By definition, it would have to travel at different speeds. Now, wouldn't it?
It's traveling the same speed around this circle, and it's daylight for.
But then you just said it's down below 6 months later, traveling a bigger circle, right? And it does it once every 24 hours.
Correct. I don't see the sun traveling different speeds.
It would have to be traveling at different speeds then, wouldn't it?
No, because we have less daylight.
No, the speed at which it travels across the sky during the day is always 15 degrees an hour.
Always 15 degrees an hour.
Yes. You take your fist at arm's length, the
Correct.
sun or the moon will cover that in about an hour. Actually, about 45 minutes. Most people's fist is 10 degrees.
Okay.
Do you see a problem with that? Yeah, it doesn't work for what we observe. So that model can't be accurate that the sun is traveling in different circles above the flat earth, or the sun's velocity would have to change. It don't work. The math don't math. Alicia, thank you for the subscription for Parker.
Let me find you something here, because you're saying the math doesn't math. I believe the math.
That's why there's no mathematical flat earth model. People do drawings, but that's not a model. A model is making predictions. So, for example, on April 8th next year in North America, I'm going to be able to tell you exactly the path of totality of the solar eclipse and who's going to be able to see how much of the eclipse, depending on whether you're north or south of totality. By the way, that path also tells us how far away the sun is, because we can do the angles of what a part of the eclipse. That tells me the distance to the sun and the moon.
Hold on one second, gentlemen. I'm trying to pull something up here.
In the meantime, everyone keep tapping that screen. We're about 300,000 away from 2 million. Everyone, we're almost there. We're almost there.
And for everybody, while Brian's looking stuff up, if you're in North America, find the path, go to a website, dateandtime.com, and find the path. And go, if you've never seen a full solar eclipse, it is a beautiful thing to see. There's not going to be another one for like 20 years in North America. So if you're in North America and you want to see the full solar eclipse, April 8th next year, get there and see it. Whether you're a flat earther or a round earther.
Yeah, I've seen one before. We did that at my high school, like when there was one.
Yeah, I think
we had like all these glasses because you have to wear like specific ones, else like your eyes, something bad will happen to your eyes. And we saw it. It was really, really cool. Yeah, wear eye protection, everyone. Very important. Don't just look at
order your glasses now, and all this money is going to go to glasses that I'm going to donate to public schools in the Denver metro area so the students can see it safely.
Yeah, W Broncos. Someone said I couldn't name 3 Broncos players. I absolutely could. I played enough Madden to be able to do that.
Steve Atwater.
Steve Atwater. That's so long ago. I could name 3 wide receivers.
Jerry Jeudy.
Oh, yeah, Jerry Jeudy, KJ Hamler. There's Sutton. I could name multiple.
Sutton's a stud.
Sutton is absolutely wild. Yeah, he just left. If they would like to send a guest request back, do you remember their name? I could add them back in. Brian, send a guest request back. If not, I will go to the next person. We'll try to get someone up here real quick before we do end it here tonight, everyone. I think we'll probably keep going here for a little bit longer. Let's see. I don't see them in the.
I really appreciate this. Thank you all, everyone.
Yeah, no, today's been wild. We're definitely gonna have to do this again. I think the background.
More than willing to.
The background
if you want to do the Big Bang.
Oh yeah,
I can do that one too.
We're gonna have to do that sometime. We'll see. Yo, what's up? How old are you?
33.
For sure. Do you think that the Earth is flat?
Yes, I do.
Why so?
Well, there's lots of things to look at. First of all, I just want to thank you guys for your, it's a pretty respectful chat here. Besides for some of the guests, obviously it's a pretty hot button topic always. But I do have a question, that I do ask and, want to get a lot of answers from, because I kind of came into this about maybe 3 years ago. Cause I grew up kind of like everybody else, we all are, kind of go up with the globe and, heliocentric belief. But so are you familiar with kind of the top images that you're searching in Google, kind of like the image behind you? That's really not what people are ascribing to, but that's kind of
it's imagery.
Yeah, I gotcha. That's kind of the first thing is kind of like I try to tell people that that's not what people are talking about when they're saying flat Earth, like water falling off the edge, and they kind of show a flat pancake Earth in the middle of a heliocentric universe, and that's kind of the first straw man. So it kind of takes time to deconstruct that belief, because that's what you think people are talking about when they're talking about flat or level Earth.
All right, we'll go for it.
Yeah. Okay. So, how do you guys explain like long distance? There's, with the increasing of optics and increasing technology with different lensing and with ultra red technology and stuff, we're getting longer and longer distance photos. So, for example, there is have you seen the Snowden shot? So basically it's SNO DON or your WIFA. It's also YRWYDDFA. So that's going to be a mountain. And so basically, if we have two mountains and we know the elevation, and then we can calculate the distance. This is just pulling the calculations off of Google Earth. So if we just know the elevation between two mountains, and then we have the distance between the two, we should be able to do a calculation with the given accepted curvature of the Earth, and then say whether something could or could not be visible with that elevation. So the thing is, when you, and I can give you those numbers too, and I'd like to get your feedback on that, because when we type in these numbers,
which picture? What's the picture name?
It's going to be called the. Well, there's a couple different mountains. So the first mountain is the Snowden S.
No, I need to get to the image you're talking about.
All right, let me see if I can figure out a way to get that. It's like Snowden from Mount Blanc. Snowden from Mount Blanc. And then maybe you'll be able to pull up this image here. There's a really great YouTube independent researcher called Jay Tolan Media, and he's done a lot of really great long distance imagery. This is not from him, but it's he does a lot of really interesting work where he's getting super long distance imagery, and so it's becoming kind of a growing interest, I believe, because we are getting better optics, and there are certain things that should be hidden by physical curvature.
So I pulled it up, and I would have to research this particular image, but when I pull it up, the first 8 websites are how it's debunked and how the mountains are really clouds in the image. So what I would rather do, rather than talk about a particular image, talk about the Earth curve calculator, and nobody has ever beaten the Earth curve calculator at an image. And the one you're talking about, those mountain peaks don't line up, and they're cloud tops.
So, okay,
and I can show videos of it. Why don't we talk about things that prove the Earth's curve, not somebody taking a picture and making claims about it?
Well, no. Well, the thing is, there's different people that take the same photo, and obviously, depending on the weather conditions, you're going to be able to take, if it's raining, you might not be able to see a mile, but if you are seeing mountains or buildings in the distance that are exceeding the supposed curvature, that's
they're
either,
not.
What do you think about like the Chicago skyline photo? Are you familiar with that?
So So what I want to talk about is something you can observe every day, depending on, as long as it's clear, is the sun setting and rising, and the moon setting and rising if the moon rises and sets.
Yeah, I'm familiar with, watching the luminaries, but there's all kinds of things to consider when we're watching the sun. And, well, I mean, are they not luminaries?
No.
Okay.
No, because I can
of
tell
argument-
you that a solar storm just left the surface of the sun. I photographed them, and then 48 hours later, we have an increased solar aurora borealis. How am I able to make those predictions and map the velocity of a solar, a CME leaving the sun and then having the physical effects happen later?
There's all kinds
I know what the sun is.
Yeah, okay. So, but on the heliocentric model, so there is a lot of, we're looking through a dense medium of atmospheric, like we're looking through water. So obviously there's an atmospheric gradient as we get higher in altitude. And so the air is
Well, that
clear.
proves we're not in a dome. That proves we're not in a dome. And second of all, you didn't address a solar storm traveling at 1.5 million miles an hour, or one that's traveling at 4 million miles an hour, and that we can predict when it's going to hit the Earth. We send out warnings. The aurora borealis sure changes, and we had one a few months ago that got as low as the panhandle of Texas. Why can scientists tell you that's going to happen, and then it happens, and we can show you the videos in real time of the sun doing that? I know what the sun is. Are you telling me I'm not observing the sun do these things?
No, I'm telling you that as we are looking up into the sky, and we are looking not at things that we can physically observe. And so
I can physically observe it.
Well, yeah, you can observe it, but we have to admit that if we are taking into account a weighted average of different evidences, so we can't just take one piece of evidence and then tip the scale and just go back to our belief. Are we able to look at all of the weighted evidence and say, how does this tip the scale in general? Whereas we're looking at the sun, and sure, it's a great litmus test, but why not looking at other things? Like I'm saying, long distance curve. Sorry, continue.
Okay, so you're taking a couple photography images. I'm going to take the sun rising, sun setting, the moon rising, the moon setting. My ability with a friend of mine 500 or 1,000 miles away to triangulate the moon and measure its distance to 240,000 miles, being able to use the physics and I'm just using trigonometry and just the tangent function to do that. And then I can determine the distance to the sun. And then I can observe the sun and it throwing out solar storms and us seeing those activities. I am also going to be able to predict the eclipse path on the curvature of the Earth. It is a straight line, but when you project it on the globe, it is curved, and only globe math using ephemeris will tell you the exact path and date and time down to the second for a solar eclipse or a lunar eclipse. These are just 4 methods. I can give you another 900 phenomenons of the globe.
Yeah, for sure. And like I said, I think there are different evidences for different sides, and
I appreciate the subscription. Thank you so much.
I'm fully aware of the heliocentric claims, and so can we at least
they're more than claims. They make predictions, and those predictions always come true. So they're not just claims; they're predictions. Are we going to have an eclipse on April 8th, and was it using ephemeris? Do you want me to do the math on the April 8th eclipse and show you the path of totality using ephemeris?
Are you saying do you want me to do, or are you saying do you want me to have you do those calculations right now?
Yeah, we can show you the math for the April 8th eclipse, and we weren't able to predict eclipses other than it was eclipse season into the 1700s until, or before the 1700s, we could say it's possible you could get an eclipse this day, but we wouldn't be able to tell you when and where. Starting in the 1700s, after Johannes Kepler, we used ephemeris, and we can actually tell you the exact path an eclipse will take on the Earth. Is that not like making a prophecy? The eclipse will happen here. It'll start at this time. This part of the Earth will be covered. That's more than a claim. That's a claim that always comes true.
Yes, exactly. So I'm not denying that there is predictions. So I mean, are these predictions not built off of past observances that we are tracking, and this is a continually new process every single time?
So if you do the math, I can tell you that an eclipse is possible, but until I use the curvature of the Earth and the heliocentric model, I can't tell you the path the shadow will take on the Earth. Nobody can do that up until Johannes Kepler in the 1680s came up with the laws of planetary motion. So I can tell you that it's possible that there's an eclipse because there's 2 eclipse windows in the Earth's orbit and the moon's orbit. But it may not occur because we don't always have an eclipse every 6 months. And it doesn't cover the exact part of the Earth. And nobody has built a flat Earth model saying this is where. And there's a $10,000 challenge for somebody to make a prediction of an eclipse on the flat Earth. No one's won that.
Okay, so I mean, obviously we have different evidences, and I don't have an explanation for the prediction of eclipses, but I mean, I would like to bring up other, I don't want to hopscotch, but I do want to bring up other questions on the topic of, one versus the other, if that's fine.
Sure.
Okay. So you had mentioned that you're a pilot. Are you allowed to disclose kind of some of the paths that you've taken in your career?
I'm just done Cessnas. I've only got about 100 hours, and most of that was in the 90s. But I do understand flying because I did get an instrument rating.
Nice.
And I do work with a bunch of pilots once in a while.
Yeah, very cool. So with the SR, are you familiar with the specs on the SR-72 aircraft?
The SR-71, the Blackbird?
Yeah, I guess there's a proposed SR-72. It's called like Son of Blackbird. It's kind of is that an what'd you say?
It doesn't exist as far as we know.
Yeah, that's what I was kind of asking. I mean, it's on Wikipedia as like they are planning on creating this aircraft. So I wanted to pull some specs from that. I could pull from the SR-71, which is a little bit slower, if that's okay.
It's fine.
All right, let me just pull this up so I'm sure I'm pulling. Is Wikipedia fine for?
Yeah. I don't know where you're going with it, but go.
All right. The top speed. Let me find out.
Interesting fact about the SR-71 is it was designed using slide rules. We didn't have digital calculators when the SR-71 was designed. It was all designed on paper and slide rules, not even computers.
That's wild.
Kelly Johnson.
Sorry, let me just.
And that it leaks. Go ahead.
Oh,
it leaks like a sieve when it's on the ground, and then as the titanium heats up, as it accelerates, it all seals.
Yes. 71.
So I might know a little bit about the SR-71.
No, yeah, that's pretty cool. I guess it was decommissioned. Was it in the 80s, I believe?
Late 90s.
Late 90s. Very cool. So let's see, operating at high speeds and altitudes, Mach 3.2 at 85,000 feet. I'm trying to find the top speed here.
It's around Mach 3 is all they release.
Okay, so in miles per hour, that's going to be, do we have?
Depends on the altitude, because Mach is dependent off the altitude, so you have to do a calculator.
All right, let's see. So on the low end, on low altitude, low end, what would you say? Like,
oh, let me look it up.
By the way, I think
roughly about
2,400
miles per hour.
okay, yeah, I see it here. So 20. This one says 22. So okay, so say we have like a hang glider, right? So if you're flying a hang glider and you're going 20, 30, 40 miles per hour or something, maybe a mile up or whatnot. After you're cruising, so depending on like the weight of your aircraft, if you have a lower weight aircraft and you can cruise at a lower speed, for lack of better terms. So say we're flying the SR-71 at, let's say this is, what would be like minimum cruising speed for this aircraft? Like a standard 747 is 500 miles per hour, something like that.
Let me look it up.
And I do just want to say, I think in 15 minutes or so, I am going to get off. Just letting y'all know.
Thanks for having me up here. Everyone, tap the screen. Give Parker a follow if you're a follower of mine. He does these debates on all kinds of topics. Great person. Give him a follow.
Also, follow Nixie if you haven't already. He does a bunch of good streams that are very educational all the time. So make sure, if you have not already, make sure to follow Nixie. But we're definitely going to be doing these in the future as well. So make sure to look out for that as well, everyone. But yeah, follow if you have not already. We'll be back, everyone.
About 300 miles an hour, roughly, is what I can find.
Okay, so say the SR-71 is
250.
Okay, gotcha. So say the SR-71 is flying at approximately 250 miles per hour at cruising altitude. So it's flying effectively parallel with the Earth. So we have at that speed, essentially the gravitational effects for the aircraft have been canceled out due to the thrust of the aircraft.
The lift of the wings.
Well, yeah, the lift of the wings and the thrust of the aircraft.
Has nothing to do with it. It's not the velocity, because the plane can fly at different speeds.
Yeah, sure. So, but the thing is it's cruising at this altitude, and any speed that is beyond that is essentially going to be excessive. Like at that point, the aircraft is not needing to go at a faster speed in order to maintain altitude. So at 2,200 miles per hour,
trim your flaps. You trim your flaps depending on your velocity. You will trim your flaps so that you would get downward or upward thrust. So when a plane starts accelerating like an F-15, I've gotten to ride in a couple F-15s, the flaps will be like this or like this, depending on what altitude the pilot wants to keep. And that's based off barometric pressure.
Yeah.
So based off your velocity, you have to trim the flaps.
Yeah, I agree. So what I'm kind of getting at is that any excessive speed beyond that is not going to, any excessive speed beyond what speed you are cruising at is not going to be essentially the gravitational pull adhering the aircraft to the Earth, right?
No, you're missing the whole principle of lift. That's why you trim your flaps. So you should look up what trimming your flaps are on an airplane.
Yeah, I'm familiar with. That's how you are essentially gaining and lowering altitude by trimming your flaps.
No, if I accelerate, I'm going to trim my flaps to keep the same altitude because I will generate more lift. So I have to counter that.
So, okay. So on like kind of the first page of Google, everybody says that the Earth is curving at a downward curvature of 8 inches per mile. I've been told that's wrong. So what is
That's wrong. It's 1 degree every 69 miles.
1 degree based off of 24,000 plus miles in circumference?
1 degree every 69 miles. There's 360 degrees and the Earth is roughly 24,000 miles round.
So
it depends on where you're flying and what your path is, what that's going to do. So what are you getting at here? You're land your plane here.
Okay. So if the aircraft is flying over a constantly curved surface, obviously it's not perfect, but it does have a consistent downward curvature due to a spherical Earth, then how is the aircraft, is there a certain speed that the aircraft would need to adjust in order to adhere to be level with the ground?
I'm always adjusting it because the way we keep an airplane at the same altitude is based off barometric pressure. That barometric pressure changes. So when you go take off from an airport, you figure out what your barometric pressure at the airport is and you zero out your altimeter. Your altimeter is not based off radar. It is based off a pressure gradient. And the reason why we use a pressure gradient is two airplanes coming from different cities, and if they're both at 35,000 feet, they could hit each other. So we keep altitudes of 2,000 feet between cross going otherwise. Well, all aircraft in a region set their altimeter to the exact same barometric pressure. So they're always adjusting their altitude up and down based off the air pressure. So you're flying an air pressure gradient that's relative to the height. So the pilot is always, or the autopilot is always making small adjustments.
Okay, so the autopilot is essentially,
or the pilot, you're keeping it at the same altitude in the pressure gradient.
Yeah. Okay. So, but isn't that essentially the same thing as saying that you are either as the pilot or the autopilot is adjusting for the downward curvature of the Earth?
No, you're keeping it you're making it harder than it is. You're keeping it in the same pressure gradient. That pressure gradient is roughly the same altitude above the Earth.
Yeah, but as the ground is constantly curving downward, it is in effect doing the same thing.
You're always keeping in the pressure, and you may have to nose up or nose down to keep it.
Okay, well, yeah, that's kind of what I'm getting at, is that there is, because it's kind of, I don't know, it kind of depends on who you ask. They say, no, the gravity will keep it, in relative parallel to the Earth, no matter what speed you go. So if the SR-71 is going 2,200 miles max speed.
And that would be at 85,000 feet is the only place it could do that. And that would probably be north of that altitude. It's going to stay at 85,000 feet based off barometric pressure. And if the pressure changes, it will adjust for the pressure change.
And do you think that is felt? So say, hypothetically, at what speed would you feel?
You're constantly doing it.
What speed would you feel?
Don't know. The SR-71 wouldn't feel it because you're constantly making these changes. There are air pockets. You're always adjusting stuff on airplanes.
Okay, well, yeah, that's kind of what I'm getting at. But I mean, it's kind of, for most people you talk to, they say, no, the gravity is just going to continually, almost like you have,
it's air pressure.
Yeah. Okay, nice. I guess, do I have any, you got to head out? Is this?
Yeah, I do. Is there anything else you want to address? You can address stuff. I got a few more minutes.
Yeah. So, with satellites, are you up for a satellite talk for a few?
Sure. We have about 9 minutes or so.
Okay. So, is there a reason why if you type in just, GPS satellites, and just you try to find images. Now, I'm familiar with the images of the ISS, because we do have images of those.
Look up how far away a GPS satellite is, because they're in geosynchronous orbit. So Google, how far away is a GPS satellite?
Yeah, I'm familiar with the different altitudes that they say they use satellites.
So how far away is a geosynchronous satellite?
W2 million likes in the chat, everyone. W2 million likes.
Oh yeah, let's get to 2 million for Parker. Parker, thanks for having me on, my friend.
We hit 2 million.
2 million.
Let's go.
So 12.5, 12.
So follow if you haven't already, everyone. We're almost at 2.5 thousand for today. That's crazy.
Yep.
So
12,500 feet, or 12,550 miles, something like that.
Yeah. I mean, so what does that have to do with what you were saying?
Okay, now keep talking.
Okay, yeah. So why is it that when we type in GPS satellite photos that we get something that is a little bit different than when we type in images of other technology that we have anywhere else in the world?
You mean like ISS pictures?
No, not ISS, but GPS satellites. So there's thousands of satellites that we're told are everywhere.
Hundreds.
Okay, hundreds of satellites. Sure.
There are hundreds of GPS satellites, and you too can find them. They're points of light out there.
I'm just talking about like actual photos of satellites. Do you see those on Google when you type that in?
What do you mean, photo? You mean me on Earth taking a picture of a GPS satellite?
No, I mean like when we have different types of technology. We have all types of different aircraft that are being created, constructed, that are in different stages of construction. Why is it that the image search for GPS satellite photos are consistent with artistic renderings and such like that?
Oh God. Okay. You want pictures of them? Okay. Here we go.
And I'm not trying to be facetious. I'm just literally, looking at.
No, here's one. Here's one. Here's one. Here's one. Here's another one.
We can't see you. We can't see your camera.
Oh, I didn't hit save. Sorry.
You're good. Don't worry.
Here's one. Here's another one. Here's another one. I typed in GPS construction.
How old are these photos, would you say, judging by the...
Well, sorry. Was putting my charger back in.
I'm here.
So if you want to know GPS satellites exist, is that what your real question is? Let's get to the end, Bison.
I've just never seen technology that is so elusive to find photos when it comes to...
Well, I just found them.
Technology that these photos... look very...
Yeah, I just found them. So, yeah, they're there. But people don't really care what satellites look like. But do you want to know how you can determine they're there?
Yeah, go for it.
Okay. In my bio, you can find my link tree. In there, you can build your own GPS receiver. That receiver will receive a signal from the GPS satellites. And guess what that receiver tells you? I'm located here on the celestial sphere. It'll give you its right ascension and declination, basically, and it will tell you what time it is. That's all a GPS satellite beams. This is all the GPS satellite does, is send out a signal of this is where I'm at and this is what time it is. That's all it does.
I agree. We have the technology there.
Hold on, Bison. And your cell phone reads multiples of those, so you can build your own receiver, and it does the math based off where they're located and what time it is to tell you where you are on a projected globe, down to the meter. You can do the math and you can receive those signals, and that's all those signals tell you. So how would that not prove the Earth is a globe?
Are you familiar with the Google Loon project?
Yep, that wouldn't work because this tells you what time it is and you're triangulate multiple satellites based off time. So it wouldn't work.
So, okay. So essentially, if we have geosynchronous satellites, which are told to be telecommunication devices that are geo-locked in orbit, right? According to, okay. So they essentially don't move. I mean, if they stay in place relatively to the relative.
They're orbiting at the same the 15 degrees an hour, the same speed the Earth is rotating.
Yeah, sure.
Right.
Okay. So if we have Google Loon projects, which are essentially
forget Google Loons, we're going to just talk about one subject: GPS satellites. They tell you where they are in the sky, and they have to always be in the same spot. And we know that they're 12,000 miles away because we can triangulate them because they're a little dot in the sky like a star. But depending on what latitude you're in, they're going to appear different relative to the stars. So I can tell you they're 12,500 miles away, and I get a signal from them telling me this is where I am and what time it is. They don't tell you your location. You calculate your location based off where they are. They're basically artificial stars.
Exactly. So I'm not trying to hopscotch subjects, but I think that it is relative. It is relative information with the Google Loon project because essentially we have the same technology that's on these huge giant. Because 99% of the.
Oh, you're cutting out. By the way, I think I just have time for like final thoughts, real quick, and then I am gonna end it real quick.
Let Bison get his final thought in.
Oh, and by the way, everyone, if you can't do Cash App or Venmo or do the gifting through subs, if you can't do PayPal, DM me on my second account, and you might be able to get it through that way, or just like come through my a second account live later and just like message me there on the live. But yeah, continue.
Yeah, I'll head out, but I just there's a lot to talk about, so I'll jump off for now. But thanks for the conversation and appreciate it. I'm not hooked up with the gifting thing yet, but my account's not hooked up with that yet, but I'll jump back on some other time and appreciate the conversation, guys.
I appreciate it, man. Thank you so much.
Yeah, you too. All right, good night.
All right. Thank you all for coming in. If you're a follower of mine, follow Parker. We'll do more of these. Give Parker your ideas. Thank you so much, Parker. Remember,
of course, man.
There's more than 1,000 phenomenons that show the Earth is a sphere. You only heard about 10 of them here. I know another 990.
We've got a lot more of them to go through. So a lot more content material to go through specifically for this topic. Let me know how y'all liked it and whatnot. Follow me if you have not already, as well as follow Nixie, especially if you have not. He does a bunch of educational lives. I'm serious. I want to see a bunch of y'all in some of Nixie's streams later. You can catch me in some of them every once in a while. They're very, very educational. I'm not joking. Definitely go check it out. But yeah, no, I appreciate it. I appreciate Nixie. I really do, man. Thank you so much.
I want to tell you one other thing.
Go for it.
I'm going to be in California in January. I got in the TikTok Fest. I am one of the 100 creators.
Yo, that is so cool. That's cool. Is that in Los Angeles?
So thank you. Yeah, that's going to be in LA.
Dude, that's so cool. That's so cool. Definitely.
So thank you for all that support. And thank you all. Follow Parker. Take care, everybody.
Appreciate it, man. Appreciate it. Have a good day, bro. All right, everyone. I appreciate everyone. We're going to go raid someone real quick. I think we're going to raid Harry. So everyone look up Harry J. Sisson. Spam Parker raid. Spam love from Parker. Everyone look up Harry J. Sisson, spam Parker Raid, spam love from Parker. Nico, I appreciate the $10. Thank you so much. If you do want to support me, Venmo, Cash App in the bio. You already know the deal, but everyone go to look up Harry J. Sisson, spam Parker Raid, spam love from Parker. I might be on battles later, everyone. So if you do want to support me and you can only gift through TikTok, I will be on my battles on my third account. Parker Needs a Job later tonight. Definitely within a few hours. I'm going to go eat and do other stuff real quick. But everyone go to Harry J. Sisson, spam Parker Raid, spam love from Parker. Love y'all so much. Have a fantastic night, everyone. Peace out, y'all. Love y'all so much. Again, Harry J. Sisson, spam Parker Raid, spam love from Parker, y'all.